Welcome to our presentation for Microsoft Azure Architect with the AZ303 exam cram. In this session, we're going to be going over the exam as a general principle, what's going to be covered in it. We're going to be focusing on the major sections of the AZ303 exam, including implement and monitor in Azure infrastructure, managing the security solutions, as well as implementing the solutions for apps and implementing and manage data platforms. The exam is one part of a pair of exams that lead to the expert level Azure certification, Microsoft Certified Azure Solutions Architect Expert. This particular exam is the Microsoft Azure Architect Technologies. With being the technologies one, it's focused a lot on the different aspects within the organization, within the Azure space, and focusing primarily on the resources and types of technologies and management of them. The breakdown of the exam is in these main 4 sections. You'll notice the implement and monitor in Azure infrastructure is around half of the exam. This is definitely the bulk of it, where they focus a lot of their pieces around it. And by the end of this session, you'll have a better understanding over all of what the exam is going to be covering. What the implement monitor Azure infrastructure, they'll be talking about analyzing resourcing utilization consumption, creating configuring storage accounts, configuring virtual machines for Linux and Windows, automation of virtual machine deployments, managing and implementing virtual networks, managing Azure Active Directory, managing and implementing hybrid identities, as well as creation of connectivity between virtual networks. When you move into the implement, manage, and security solutions, this is where bulk of the security and analyzing piece aspect of it, as well as the authentication and is there. The additional options then sections become the implement solutions and for apps. We're focusing a lot on the application management. It is definitely a small piece of it, but is definitely a very key, important aspect of the solutions, and it is something you need to understand. And then finally, the implement and manage data platforms. And the duties covered in the sections are largely around the storage, as well as the database structures and management platforms around that. The exam has a total allotment of about 180 minutes, where there's 150 focused towards the questions and 30 minutes for comments, score reporting, etc. There's going to be around 40 to 60 questions as an adaptive exam, so it will vary depending on what you're doing. The questions primarily going to be multiple choice. There's also going to be a lot of choose the correct 2 to 3 answers, as well as drag and drop. The drag and drop will consist of not only placing them across, but also in order frequently. So you'll have to know the priority of certain entries. There'll also be some case studies with questions, where basically you'll be given a case study and then there'll be questions relating directly to that case study, multiple questions in that grouping. And then a lot of times there's a live environment, which is based around the actual how you navigate in the environment. So it's very key that you're familiar with at least the interface, as well as getting around in that spaces. So the first section that you come to when you're looking at it, and again, this is the bulk of the exam where you'll see a lot of it, is the implement and monitor in Azure infrastructure. This case, we're talking about monitoring the cloud infrastructure, as well as implementing the storage accounts for those resources in the environments, implementing the VMs for both Windows and Linux, automating the deployment and configuration of the resources and the networking that are needed for all the infrastructure pieces with the VNets, looking at Azure Active Directory, and also how to integrate that with on-premise with hybrid environments and what are needed around that. So this is where you need to focus probably a lot of your knowledge and training around it, but it's not the only place, but you can definitely get a lot in here because there's a lot of topics that are actually covered by this environment. You just start with when we're talking about implementing cloud infrastructure monitoring. There's monitoring the security, the performance, the health, and the cost are all different aspects of the monitoring. They use similar tools, but they all have their own general aspect of what they're doing. For instance, when you're looking at monitoring security, you're looking at using the security center for a lot of that. You can also talk about utilizing Sentinel for some of those pieces, but the bulk of it usually is around security center, because that can also include the policies around monitoring the compliance of those policies in those environments, as well as any threats and problems that come up in the other environments of the monitor. So Azure Security Center is a key piece of that. When we're monitoring performance, we're talking about getting the different metrics from the virtual machines as well as applications, PaaS services, getting a lot of those details on it. And, the other aspect then becomes triggering off of those. So if you have particular metric that you're monitoring for your performance, triggering off that. And also monitoring the health and the availability. These come into play along with those logs and metrics as well, making sure that you identify which systems you can monitor, and understanding how you can set up those alerts so that if a particular performance metric gets below a certain level or above a certain level, you can alert off of those. And then finally, there's the monitoring of the cost. This is around dealing with budgets, and dealing with the alert cost and budget alerts around setting up your environment and understanding where those costs are going. And then finally, there's the configuring the advanced logging. In those particular environments, we're talking about actually setting up your virtual machines to log in there, as well as potentially third-party environments. You can set up syslog to come into the log analytics and getting the data. Once you then have all those logging details into it, it's then talking about interlacing those particular pieces. You can cross-reference from your firewall VNA that you maybe have, virtual network compliance, getting the syslogs out of that and cross-referencing that with maybe your application performance or virtual machine access. You don't necessarily need to know the in-depth of how that happens. You just need to understand that that's why we do that, and that's how we do it, is through the log analytics and through joins. You also find out later the Custo query language that log analytics uses is probably something you need to at least understand the concepts around. You need to at least understand how those are structured and how you build those out. We'll look at that in a little bit. Then you also have initiating the automated responses by using action groups. You need to understand what an action group is and how it works. The idea behind the action group is basically you're setting up a method of notifying people. You define that as an action group, so it would be emailing a particular address, maybe sending off a text. You can also set up an action group to trigger a function or a logic app, so that you can have some automation around the reactions to it. Action groups can be reused between different alerts. So you could set up an action group, for instance, for your IT team to be notified if a particular system goes down. You can then set up your alerts to monitor for your virtual machines if it's down for we haven't received a heartbeat in the past 10 minutes or something. You can then send an email off to the IT team, and the action group could either be a distribution list, or you could list off each individual person of your IT team to get that alert. You can then have further actions where if maybe a machine is reaching 80% and you want to spin up another machine, or you want to maybe resize it, don't mind doing a quick reboot in order to resize the virtual machine. You could actually set up the action group to call a runbook with your Azure automation that would then trigger and resize the virtual machine. And those are the types of things you with the action group. You don't necessarily need to know how to do all those. You just need to understand that's what the action group does, is that's the notification piece that you configure. The alert is going to be triggered based on a condition that you set, where you're looking for a particular metric or log count from your log analytics. And then the action group is telling it what to do with that trigger. Do we email somebody? Do we send a text? Do we trigger off another automation task? then configuring and managing the advanced alerts. So once you've set up these alerts, how do you manage it? How do you keep track of it? Where do you go look and see which ones are available? Which ones are triggered? How do you respond to it? Because there's also a workflow built into the alerts. There's a state when the alert's first created, it's a new state, and then once you're verified that somebody has seen it, you can acknowledge the alert. Once the alert's been resolved, you can move it to a resolve state. So there's that workflow process built around the alerts too that you need to make sure you at least understand the concept around. When you're creating the alert, you need to pick out what the alert's going to be, what the signal is. The signal is what we're talking about when we are triggering off of it. What is that event that is identified that something has happened that we need to be alerting on? That's the signal. Then you need to specify the logic around it. All right. The whole idea behind the alerts is that it's a proactive measure. It's something that we're, rather than having to send somebody out and try and deal with something after it's happened, you want to try and set these alerts to where you're reaching a point. You can watch the metrics, and if it's going up at a certain rate, or if you've seen a certain value for an extended period, maybe you've seen the disk space starting to get low, and then triggering an action to happen on that. So we have those signals that are going to be our triggers for the environment. They can be metrics values, they can be just log searches within the space, it can be activity log events. You can have a health of the underlying platform. We have the Azure platform itself. You can also do HTTP triggers, where you can go off and try and hit a website and see if we're getting back a 200 response code saying everything's good, or if we're getting something like a 404 or 500 indicating that there's a problem. Regardless of where you create the alert interface is pretty common through all of them. It's the same type of setup. We have the signal, we have the actions, we have the action group. They're all very consistent in the environment. This can be whether it's a security alert or just an event as far as somebody making a change or performance alert. So again, the big things to think about when you're talking about alert is the target, is who you're going to send the alert to. That's going to be the action group. The signal, which is going to be the metric or log analytic entry or whatever other event in the environment is going to be your signal. And then the logic is how we're dealing with that, what we're going to be doing with it, whether it be logic app, function app, or something along those lines, or just sending it to the action group. One of the big things is when you're working with any environment, Azure is working with storage accounts. Storage accounts are the basic core storage environment in Azure. We're looking at, there's the selecting the storage options around the selecting the storage options of the storage account based around how you're going to use it, the use case. You want to make sure you understand how you configure the Azure files as well as the blob storage, configure the network access to it, the shared access signatures, Azure AD authentication, the manage access keys, the storage replication, the storage account failover. Okay. When we're talking about these, the storage account options based around it, there's the V1 and V2 of the storage accounts, which really add on how many features that are available to it. And then there's also the blob specific storage and then the file specific storage. And you need to understand the concept between those. The standard storage accounts, the general purpose ones, version 1 and version 2 give the options of doing blob, file, queue, and table. Okay. The Azure files and the Azure blobs are the general types of storage. If you're unfamiliar with the blob storage, the idea here is that you have just a generic binary data be stuck out there. It can be a text file, it can be a Word document, it can be a video, it can be an audio, it can be just a small blip of data, but it's going to be a block that we're going to just store data out into it. There's no real organization behind here. You can do folder namings and the name of your blob to help it be understandable to you, but there's no inherent tree within the blob space. With Azure Files, you have the ability to connect to it as SMB, which is your standard Windows protocol. Also, CIFS is what's also sometimes called, but SMB protocol that you can connect into those files. So it can be like a network share, just like you have on your on-premise files. Nice thing about the Azure Files is that it does give you a tree structure that you can place files into. You can also set up NTFS permissions like you do in a file share. You need to understand that the files are a structured file structure in the sense of it's files, but it's not structured in the sense of being database. So it's still, not a strict structure. It's just a file table. So it's really unstructured data because we don't have a strong adherence to it. It just gives us some files based in tree structure. The access to the files and the blobs, beyond just the basic RBAC access that you would have into the environment, is also the data plane. There's two control access for the blobs and the files. When you're working in Azure, there's the management plane where you're doing most of the management within the portal. This is, gives the ability to create a resource, change its configuration as far as, how many containers or what the size of it is. Those types of things are done at the management level. Then there's the data plane interface. That's when you actually connect up to a share, connect up to a blob container, where you're actually storing the data. Those are a different set of permissions. So you need to make sure you understand that there's the management of the storage account, and then there's the control and access of the data within that. Those are two different permission structures. Now, if you do something like a standard owner, they have access to everything regardless, or a contributor, they have access to everything. They just can't change permissions. When you deal with the data plane, though, there's additional roles that you can give that contribute directly to the data plane. Configuring network access to the storage account, when talking about that, they're talking about the actual firewall, the actual control, and who has access to the basic interface of the storage account. This does not prevent somebody from authenticating to it if they're in the firewall range. So just because you may have granted an IP access to the storage account, that doesn't mean they have access to the data within that storage account. It just means that they're actually allowed to potentially authenticate and then have access to it. Okay. But if you deny access and you've explicitly said these are the only places I want to get to it, if they're not in that space, they won't even be allowed to even try to authenticate, regardless of what type of access you give them. You need to understand the concept of a shared access signature. SAS keys is what they're referred to a lot, SAS, but that's what it stands for, shared access signatures. These are temporary keys where you give access explicitly to either a container or the entire storage account or a particular blob within that space, and you can define what type of access they have in the shared access signature. You need to understand, why to use those, when to use them, and maybe some of the pitfalls. The main reason a lot of times you use them is to give access to an application temporarily, maybe a user temporarily access to a particular space, and only giving them certain areas you have access to it. You need to make sure you understand that that's what it's used for. You also need to understand that just sharing out that signature, if somebody sends that out, you can't necessarily control that, who else they gave it access to. Now, if you combine that with the firewall, you can at least limit the exposure, but it is one of those, if somebody has access to that signature, they'll immediately be able to get into that same realm. So you need to make sure those are secured just like you would any other key. And then finally, you need to also understand what the Azure AD authentication is. We now have the ability to integrate directly with Azure AD to get access to the environments. Okay. That gives you the ability to authenticate for your data access. With your Azure AD account, you don't have to use these keys in order to access it. Also, there's management access keys that give you direct access and into the storage account. They give you full access. These are two keys that are fully have access to it. Okay. In addition, you need to understand the disaster recovery solutions. We're talking about storage accounts. So storage accounts give you the option of doing a few different replication methods. There is the local redundant storage. When you're talking about local redundant storage, you need to keep in mind that that is literally just within that set of racks. It's basically saying that it's replicated to multiple different drives. So if there's a physical failure in that rack or in that set of drives, your data is going to be insured, but it's just locally in that space is redundant. If for whatever reason that section of that Azure region goes down, you could potentially lose that data in that storage account. So that's where they talk about the ZRS, zone redundant storage. In a zone redundant storage structure, that's where you have data in multiple different places in the data center. You have multiple different physical regions separated within that data center. However, if you have a region-wide outage, whether it be a massive failure, environmental disaster like a hurricane or some other major issue that causes that region to go down, that data could potentially be lost. So then we talk about GRS, globally redundant storage. When they talk about globally redundant storage, that storage account is going to get replicated to the paired region for that. What that means is that in the event of the region goes down, that data would then be available in another region. Okay, that gives you the GRS. However, the GRS is only going to be available in the failover region if it's actually failed over. You will not be able to access in the other region until that failover takes place. There is then the RAGRS, that means read access global redundant storage. We're talking about that one, we're talking about an actual the ability to read it in the failover region before the failover happens. It just gives you read access. This is very useful for those scenarios where maybe the failover is going to take a while. You want some time to figure out whether or not you need to actually trigger a full failover, or maybe you just want to have a little bit faster access in the failover region, so you have a little bit less latency. That's another option. One problem with the GRS setup is that if you are in a region and your particular zone where that data was stored failed, so that area of the region failed, that data wouldn't necessarily be available. Now, it would be over in the failover region if you trigger failover, but it wouldn't necessarily immediately be available in that same region. You would have to failover to an entirely different geographical location for that. And then that's where there's actually now combination ZGRS, zone redundant, geographically redundant storage. Where the ZGRS, basically you are replicating to multiple different zones within a region, and you're also replicating that over to a failover geographical place as well. So that's where you can get a little bit of options there. The storage account now gives you the ability to manually fail over when you do the GRS option. In the past, this was something that would be handled only by Azure support and only in the event of a disaster. You could submit a ticket and they would go through it. If there was an actual region failure, there was a process where they would go through and trigger this. But you could submit a ticket and ask them to do it, but it would take some time to do this. They now give you the ability as the management owner of that storage account to go ahead and do those failover pieces. It's a little bit of redundant statements. Another key piece of implementing and managing, you need to understand implementing virtual machines for Windows and Linux. You need to understand the ideas of the high availability options with virtual machines. The main ones being availability sets versus availability zones. You need to understand the storage options for virtual machines, selecting the virtual machine size, what the impact is of different sizes and how to change those sizes, implementing the Azure dedicated hosts, deploying and configuring scale sets, as well as configuring Azure disk encryption. One of the big things you need to keep in mind when you're doing the high availability is that this is really something that you're going to do at the time of deployment. You need to keep in mind that if you need to change the availability, it will actually take the process of destroying that virtual machine and recreating. You can sell the disk out there, you can sell the NIC, but you would have to destroy that virtual machine object and then reattach the disk and reattach the virtual machine in order to set up a new availability set. So you need to think about that when you're setting up a virtual machine, is that you need to set the availability set on where the availability zone was created. You also need to keep in mind what the high availability levels are for virtual machines. If you have a virtual machine that's running on premium storage, the SLA is 99.9%. If you're looking at the availability for a availability set, it is 99.95 for an availability set. And then for availability zone, it's 99.99 availability. Okay. So as you go up between those different levels, there's different levels of high availability. The SLA is only, again, for a single VM with premium storage, 99.9. That's the lowest level at premium storage. And you need to think about the storage when you're configuring the VMs. There's the option of doing it to an unmanaged disk, which goes into the storage account, or the managed disk, which is its own separate resource within Azure that you can manage independently. With a managed disk, you have the ability to change its performance, and you can move it between the different tiers. The different tiers being standard HDD, which is similar to a spindle traditional disk. That's what the HDD stands for, is hard disk drive. Then you have the standard SSD, which is, or excuse me, SSD. Standard SSD is a basic solid state drive, that's the SSD, but it is still standard level, so it is not quite the premium. You do get performance boost from the HDD, but it is not quite the premium level. The first level premium is premium SSD, and the premium SSD, this is when you get into the high performance solid state disks. And then finally at the upper level, you have the premium ultra HDD, rather, you have the Ultra SSD. The Ultra SSD is the high level with very high IOPS. You also need to understand when you're talking about the storage, when you size a disk, depending on the size of the size of the disk is going to depend on what type of performance based on different tiers of managed disks. So when you have a premium SSD, if you have a 64 gigabyte drive, that's going to have a certain performance IOPS and performance bandwidth. Whereas if you do a terabyte SSD, it's going to have more performance and more IOPS, more throughput on it. However, there's also limitations to that performance at the VM level. So different size VMs have a maximum IOPS, and they also have a maximum throughput for the classification of a VM. For instance, like a D4 has a limitation of how many IOPS and how much throughput it can have, regardless of how many disks you attach to it. So when you attach multiple disks to a VM, it is possible that while the disks, if you add them all together, could have a certain level of IOPS, all of them together. If the VM has a cap that is below that, that is what your performance max would be the VM itself. So there are two levels of that performance when you're looking at the storage. You need to keep that in mind when you're planning those out. There's also a certain number of disks that you can apply to different tiers of virtual machines, so remember that as well. The main thing, obviously, when you're picking the virtual machine size is usually the number of cores, and they're all binary values. It's always 1, 2, 4, 8, 16. You're never going to have a 3, you're not going to have a 6. They're always 1, 2, 4, 8, 16. Some of the names of the virtual machines don't necessarily correspond to that, because sometimes you'll have there's the D2, or excuse me, DV2 generation of them, where you have a D3, and that is corresponding to 4 CPU. So there's a few things in there on that, but you need to keep in mind there's always going to be CPU and memory. The different families of processors are also going to determine how that breaks down. So when you have the CPU and you have your RAM, that would be the general purpose ones, or the memory setup, or the compute focused family of CPUs. So pull that up real quick. Okay, but the idea when you're looking at those CPU classifications is that they're ones that have a more memory ratio. So that if you're looking at the virtual machines, the memory optimized ones have a higher ratio of memory to CPU, whereas the compute optimized ones have a higher compute to memory ratio. Then you also have some special purpose ones where you have storage optimized virtual machines. Those will give you a higher IOPS for your virtual machines. And there's also the graphics into the ones that all start with the N, and they all have NVIDIA GPUs behind them. So you need to understand that concept behind them. You also need to keep in mind that a virtual machine will only support premium disks if there's an S label in the name of the machine. So you have like the D2S V2. So it's mean the second size in the D family. The S means it supports premium, and then V2 generation. That converts to the D2 V2, which does not support premium disks. Okay. So there's lots of stuff around the sizing. You just need to understand the idea behind the sizing. You don't have to memorize the actual what is a D2S V2. You don't need to memorize how many CPU and how many RAM that has. You need to understand that as you go up in the numbers from D2 to D4 to D8, you're increasing the number of CPUs that are available as well as the number of RAM, and need to understand the different general families. You need to understand D versus E versus N. As far as a general idea, you do not need, again, to know the actual numbers behind the CPU and the RAM. You just need to understand that they increase in size, and then you also need to know that the S is definitely for premium disks for storage. And those are the individual virtual machines. The other thing you need to make sure you understand is the Azure dedicated hosts. The idea behind a dedicated host is that you're basically buying a blade in Azure and you're paying for that blade. The problem becomes that you're paying for that blade whether you're using 10% of it or 50% of it, just like a virtual machine. But on that dedicated host, you can add virtual machines on top of it. So it's basically you're saying that, look, I want all my virtual machines to run in this space, and they all run together. If you can get close to capacity on that dedicated host, you can actually sometimes save a little bit of money as opposed to all the individual VMs. But there's a cost calculation that you have to do there to figure that out. Usually what people are doing for dedicated hosts, they want to have high performance because they're all physically close together. You're going to have extremely low latency. There's also, everybody's going to be communicating within that dedicated host. So think about those ideas, but you manage how they spin up and spin down on that dedicated host, those virtual machines that you put onto it. One of the big things too when you're doing the scale sets is you need to understand how to create them, understand the concept behind them, and how to manage them. A scale set on the virtual machines is basically you're saying that you have this basic image of this base core source that you're building from, and then you want it to be able to add additional machines as the load is increased and scale those back down when they're not needed. There are a few different options here when you scale up those virtual machine scale sets. You can either scale them up, based on a performance count or based on a load on the machines, and then scale them down, or you can do it by certain time windows. You can also choose to scale them out to where the ones that you scale back are the older machines as opposed to the ones that are the newer machines. The idea of if you scale up the older machines, you shut those down first, the old ones that have been running the longest. You're basically refreshing those machines as the loads go up and down. However, if you leave the oldest ones running and you only scale out and remove the newer ones when you scale back in, then that means that you're going to have the longer running VMs, so you're going to have a more consistent experience. You need to plan for the idea that the scale sets don't really have a whole lot of local storage, though, because as they scale in, you potentially are removing them, and they're not actually going to have the same data. So you usually want to make them. You don't want to expect to have a whole lot of local storage that's retained beyond the life of the actual VM, because in the scale set, you have these VMs that are coming up and down as they're needed. Okay. You can use data disks to attach to them. You can use a custom image, but you can also do deployment scripts against them. But the idea here is that you're scaling them up and scaling them down based on your load. And you can either do newer ones only and refresh the environment, or you can keep older ones and have more longer running VMs. Depends on what your deployment needs are. The other big thing you need to understand in Azure when you're working with virtual machines is the disk encryption. Disk encryption helps you protect and safeguard your data and help meet most organizational security compliance needs. You'll want to pay attention into the case study, some keywords like around organizational security and compliance requirements, something around their compliance needs. Security Center will tell you where those machines are encrypted, which ones aren't. So you need to understand what that. You need to also understand the ideas behind the encryption options. Okay. All disks in Azure currently, for the past several years, anything that was created in Azure is encrypted at rest for the Azure environment. However, a lot of times there are disk encryptions that you want to have beyond it to where you manage the storage. So if somebody were able to get access to your disk image for whatever reason, if they don't have access to your key, which would be kept in the key vault, they wouldn't be able to read your disk. So that's the idea behind the disk encryption extensions that they have available for both Windows and Linux. You need to understand how it can be done through the PowerShell as well as through the CLI, or it can be done through the ARM disk encryption templates. Again, the idea here being is that while disks are encrypted by default in Azure at rest, this disk encryption gives you an additional layer on top of it. The keys are stored in the key vault, and we're utilizing the SMcrypt on Linux, BitLocker on Windows to be able to encrypt those data within the operating system itself. So as the machine boots up, it's decrypted by Azure and it's utilizing that space, but all the data is then encrypted in the disk image. Okay. Another key topic you need to be familiar with is the automated deployment and configuration of the resources. You need to understand how you can go into Azure Resource Manager and save a deployment as a template. You also need to understand how to modify Azure templates. You need to understand the basic structure. If you haven't looked at a JSON ARM template, you need to make sure you're looking at that and looking to see what those are. You need to understand the idea behind the JSON layout, what the pieces are. I would highly recommend you get VS Code and get the ARM template that Azure has for it, so that you can start looking at the ARM templates and a color-coded view for it. Go to an ARM environment in your portal and just save off a deployment. You can just be a simple VM. You can talk about evaluating the location of the new resources, whether it needs to be in the same region, if how you do that structure, why you would do particular region. The idea here being is that certain regions support certain services, but you also have the geographic and political limitations of some regions. So there's maybe a particular region that a company has to be in for its regulations. So keep in mind as far as compliancy and that sort of thing, when they're looking at deployments. There is some latency, obviously, if you go between East and West Coast in the US, for example. However, a lot of times that latency isn't severe, but it is, there's physical barriers for light. There's only so fast it can go. So yes, there is some region that you want to do geographically close, but sometimes you also want to have disaster recovery options, and you want to have options as far as replicating the data between regions. So keep that in mind. You understand the idea of deploying from a template. How that happens. Where do you do it? Do you do it from the portal? Do you do it from command line? Yes, it's both of those. How that template works. You can go out to GitHub and just download a template, and you can either go through the portal and upload it as a generic template deployment, or you can do it through command line. You can also have nested templates where you can have one template call another template. Okay. You need to understand the idea of managing a template library, where you basically you have versioning of your templates. The JSON template formats in Azure has a content version attribute in that, so you can keep track of the versions of your templates as you make changes to them. You can understand how you do those. You can also understand the idea of putting them into a DevOps type of structure, putting infrastructure as a code, doing deployments from DevOps. There's also the idea of doing automation via runbooks. When you maybe want to size a virtual machine, you could do scaling for an via automation runbook if you want to. And there's also runbooks around starting and stopping VMs between certain time frames. There's also a lot of automation accounts around making changes to your Azure environment on the fly. There's a lot of community runbooks that are already out there that you can go out and take a look. There's a lot of ones that Azure has created, and you can go and take a look. You also need to understand the idea behind a managed account for your automation. If you haven't looked at Azure Automation, it's a basic environment where you have your runbook and you have your details around that. Talked about saving an Azure Manager, or saving a deployment with your Azure Resource Manager template. The idea here is that you can go out there and you can go and create it, just to give you an idea if you haven't seen it before. Even doing a deployment from the marketplace, which happens when you do just creating a new resource, takes you into creating this marketplace. If you want to just create a virtual machine that ran Windows Server, as an example. it's going to load up the actual template information from the marketplace. And all these values are parameters that you can use as part of the deployment. So if I did a deployment to a new virtual, new resource group, and again, selecting the size here, there's a few of the common ones. You can also see all the different sizes. You also see the cost estimates. Costing is usually done in a month. There are some views where they'll show you per hour. Costing is usually around 730 hours per month. You also see a lot of the different sizes here and the descriptions between them. Notice here we have the DS again. That's doing something that is a premium standard. You also notice in different versions they changed from a DS and V2 to a D2S and V3. But that was just a naming standard for between the versions. The convention now is to do the grouping of the virtual machine, the sizing number of it, and then whether or not it supports premium, followed by which version of it. Okay, so anyways, just creating a basic virtual machine. The B stands for burstable, by the way, not basic. Again, we're just creating the basic encryption. This again, you can do an option where you do from custom managed key or from a double management or double encryption key rather. You add on disks. We're going to go create a virtual machine at this point in time, or a virtual network at this point in time. When it comes down to the view and create, you'll notice down here the option we have the downloaded template for automation. At this point in time, the resource has not been created. However, you can go in, you can look and see what the actual template that would be deploying from. This is the idea that you need to know behind it, is that this is a standard template that's creating a virtual machine and a virtual network at the same time. The main key areas of the template are you have the parameters at the top. These are the ones that are being fed into it and give it some dynamic ability for the virtual machine template itself. The variables, you'll notice a lot of times these are calculated values. This is something that's just within the local template itself. It's not something that's changed directly as a parameter, but it does usually reference parameters. So notice here, this is based on the virtual network name that was defined as a parameter, or this one's defined by the network security name. And they're calculating out and building out what the resource ID is. And then subnet reference is a similar type of setup. The resources were the key of the actual deployment is taking place. This is what you define what's actually going to go in there. A big thing to understand when you're working with a template is this depends on section. What this means is this gives you the workflow on the template itself. In this particular case, we're creating a network interface. The network interface is dependent on making sure that a security group, the virtual network, and the public IP exist before the actual network interface gets created. The type is defining who the provider is and then what type of resource in that provider. That's what the type layout is defining. API version is another key value. This, as they go through different changes on the types, the API version will change. However, you're assured that if you do a template with a particular API version, it will be consistent. Even as they make additional changes, you can always reference that API version to always get the same experience. In addition to the name and the type and the depends on particular resource, all the setup and configuration of that VM is done via the properties section. This defines what's actually going on, how that actual resource is configured. Okay. Now you notice this network interface was dependent on network security group, virtual networks, and public IP. However, if you come down to the virtual machine, you'll notice it's just dependent on network interfaces. Okay, this again is because the network security groups actually applied to our the network interface is actually applied to the virtual machine. So those resources are the virtual machine is dependent on the virtual NIC to get created. So the workflow would be is that it's going to create the network security group, the virtual network, and the public IP, and it's going to sit there and wait to create the network interface. It's also going to wait to create the virtual machine until the network interface is created. So it creates these, then it creates the NIC, and then finally it'll create the virtual machine as the final step. And again, in the parameters is where it defines the actual configuration of the resource within the template. You'll need to know about the key functions of a that are within the template. The parameters, just basically you're looking at per parameter to try and find that value. All functions are contained within a string. They always start with a bracket, and then the function name, and then parentheses, and the name of whatever you're passing to that function. You also know concat. Basically, the concat function of a template is where you're combining multiple strings together to create a single string. In addition to parameters, there's also the variables property of a virtual machine, of a function lookup. Like here, you can reference a variable rather than referencing the parameter. And again, this was based on multiple different parameters. Resource ID allows you also to go and grab the resource ID from the current deployment. This is very useful a lot of times because you have to reference the ID for a particular configuration. However, that ID doesn't exist because you haven't created the resource. So the resource ID function allows you to go off and grab that. Resource group is also another function that's actually available in the template. And this is basically grabbing the information about the resource group we're deploying to. All deployments are usually assigned or associated with a resource group. There are ways you can reference other resource groups, but your deployment is based on one resource group that may be referencing resources in another resource group, but it's based on that resource group for its deployment. Okay. I mentioned before about wanting to have a Visual Studio Code plugin for your when you're working with templates. Just to give you an example, what it would look like, the same deployment template I was just showing you. You'll notice it gives you the actual layout of the same coloring scheme. This is very useful for when you need to be working with templates on a regular basis and helps you be able to navigate through them. Okay, there's also a nice option of a ARM visualizer. There's another great extension to help you understand what's going on in a particular template. And of course, it's not working for the demo. Here we go. And you'll see it shows you the resources. These arrows are the dependencies. So you notice here we have the virtual machines dependent on the network interface. The network interface is dependent on the security groups, the virtual networks, and the public IPs, and the schedules is dependent on that. So these are all the places that would go across. This gives you a quick visualization just directly from within the ARM template. This is the ARM viewer extension. This is also the JSON template. You can look at extensions here in VS Code. Again, VS Code is a cross-platform open source tool that Microsoft provides. So you can go off and download this for whatever you want to work with. The ARM template viewer is what gives you this graphical interface. Ben Coleman, by the way, worked really well on that. These are just a few of the other common ones I have out there, just as an example. But you want to make sure that you have the Azure view as well as the ARM viewer. Anyways, so this shows you how you can just go through the generally just get a basic template through the GUI. Even you can look at the parameters, and this is a parameters file that would then be associated with that template. And you'll notice here we're specifying in what those values are going to be based on what was typed in here. You will notice the admin password. Anything that has a secure password value in the form is never included in your parameters file. You can then add it to your library. You can go ahead and continue to deploy. You can also download it. When you download this, it's going to give you a zip file of the parameters file and the template file that you can then use to deploy another time. You can use this as a starting point to make changes to, or you can use it as an actual deployment. You can use it as a nested deployment, but these are the two files it's going to give you. You can go back to your existing deployment and do create. Okay. So just be aware of the options that you have for moving deployments. Be aware that you can also go out to a resource group. You can go out to the existing deployments and grab from there. You can grab the existing deployments, and you see that same view we saw before, the template downloaded. Just the same way. You can also add this to your library. You can add in the version, content value, keep track of it that way. As an architect, you need to understand the different layouts of the templates, how those templates work. Okay. We're talking about the automated deployment of virtual machines. You need to understand, again, how to modify those templates, what those changes are. You need to make sure you understand the configuration of the virtual machines, whether it's going to be in the same region that you're in, if there's going to be a failover region, why you would do one or the other. The main idea here being for redundancy as far as failover. You can also do some load balancing and do some processing distribution. You can always use content delivery networks, CDNs, to have cached information local to users. However, that's going to be data that's not readily changed. It's going to be relatively static content. If you have to go back and compute some value, something that's actually going to be processed by your application, that's going to still have to travel across the network, and you're still going to have network latency just to get to that. Sometimes it's worth having a application presence in Asia, as well as North America, as well as Europe, just to give your users a little bit better experience. So you need to understand the idea that maybe putting them in different major regions will help reduce latency, but you also are going to have the added cost of those resources are going to have to access multiple resources, either globally, or you're going to have to duplicate your data. So keep in mind those types of ideas when you're doing the designs. Also need to understand configuring VHD templates. The idea here being is that you can create a base image from your virtual machine, go through it, and you can then capture a virtual machine. You can then deploy from that VHD template as a new virtual machine. You can also have an image gallery where you can keep track of those images that you capture. Again, saving the deployment of resource manager and deploying the virtual machines themselves. One thing too you want to keep track of when you're doing implementing virtual networks. That's another key topic of the environment. We're talking about implementing virtual networks between each other, implement VNet to VNet connections, as well as virtual network peering. In those scenarios, what we're basically looking at is that we have virtual networks that we can connect via via virtual network gateway, which is an Azure VPN resource. But then there's also the using application, using peerings for VNets. The difference basically being is that a virtual network gateway will ensure that the data is encrypted between VNets, while peering is relatively secure because it is still on the Azure platform and you still have the data going that way. Between them, there is not implicit encryption across that peer. A virtual network gateway will ensure that that data is also encrypted while it's traveling between virtual networks. So if that is a regulation requirement, that is how you can achieve that is with a virtual network and gateway. Just one moment, there's an issue with the PowerPoint. We'll be right back. Okay, that seems to be better now. Sorry about that. So again, virtual network communications. We're talking about the virtual network to virtual network connections, we have the virtual network gateway, which allows you for VPN connections. It'll also allow point-to-site connections, which is a user connecting into your virtual network. This is especially useful for domain users, potentially for roaming users that are on the field, that maybe have a legacy application that requires access directly to the servers for some reason. That can be useful for point-to-site connections. And there's site-to-site. These are the ones that are using between on-premise into Azure. But then there's also the VNet to VNet VPN connection. It's similar to a site-to-site, but it is explicitly a virtual network connecting to a virtual network. Again, the reason why you do this is usually because of encryption, because for some reason, either regulation or compliancy, you need to have encryption between your virtual networks. The virtual network gateway gives you that. Virtual network peering doesn't. However, you can set up virtual network peering very quickly. They can be within the same regions, or you can do global VNet peering between regions. There are some different costs associated with these, but it's extremely easy to do. It's the exact same interface. You need to understand a little bit of the difference between grading peerings and different interfaces. The main thing is that when you're creating a peering in the Azure portal interface, there's immediately the reciprocal peering between those two environments. However, creating it through the command line interfaces, you usually are creating the peering only one direction. And so you have to come back and do the mirror going the other direction for it to fully connect. You can also do peering via the resource manager templates. Same idea though is that you have to do both peerings both ways. People that are used to doing peering control through the portal think of there just being a single peer, but you need to understand that there is an underlying peer going each direction. You have the peer coming from VNet A to VNet B, and then you also have a peer coming from VNet B to VNet A. Another big thing you need to understand about peering is that they are not transitive between them. So for instance, if you have A connect to B and B connect to C, A cannot talk to C. In order for A to talk to C, you would have to have a peering connection between them. You can kind of get around that using a virtual network appliance, but that's not really best practice. If you need A to talk to C, then you probably need to have them peer together. Also, keep in mind, VNet peering allows you to use private address communication between the two environments. That's the only way they communicate is via private IP. So therefore, the address spaces for those VNets cannot overlap. It is possible to create VNets that have overlapping address spaces in Azure. However, if you want them to communicate together, they cannot overlap at all. It is best practice to make sure that your VNets do not have overlapping address spaces, but sometimes there is a reason. For instance, disaster recovery scenarios, a lot of times they will have a duplicate address space in the other region so that when everything fails over, it has the exact same IP it had before and they don't have to worry about DNS updates or other changes. However, in that scenario, your production environment can in no way talk to your DR. Ask why you may want to do that is that sometimes people want to do only a partial failover because maybe they're doing only a single application and they just want to do a failover for either a test or just to get a machine over in the other area. There's a few different reasons that may want to do that. If you did that scenario, you'd have to fail over the entire environment if you had duplicate IPs because they could not intercommunicate. So that was a couple of ideas of behind the VNet peering. That's also true for virtual network gateway connections, VPN connections. You can have overlapping addresses to on-premise or to another VNet. When you go to create the virtual network gateway and create the connection, the IP addresses can be overlapping. Another big topic when you're working in it, as you'll notice by this big long list, is implementing Azure Active Directory. There's a lot of things around Azure Active Directory. Now, keep in mind, Azure Active Directory is our identity presence. It's where all of our users and groups and everything are put in. It's how we authenticate. It is a very key core component to working with the Azure space. If you don't understand this, then yes, you're going to have problems, but it's because it's really important to understanding that how the authentication is done and how it's secured. Okay. The big thing to keep in mind when you're setting up Azure Active Directory is you can use custom domains. Whenever you create a Azure Active Directory, it's always going to have a default of whatever name you give it, .onmicrosoft.com. Because Microsoft controls the onmicrosoft.com space, you're sure to always have that DNS available and valid. However, frequently you want to use your own domain for authentication because it's easier for users. That's a custom domain. When you do something like that, you need to be able to validate with Azure, hey, I do actually own this domain. So when you add the custom domain, you then have to validate it. The way you validate it is by putting in DNS records into your DNS zone to tell them, yes, I do in fact own it. You cannot assign users to a domain until it's actually been validated. Until that point in time, the domain will not be available to you. We're talking about Azure ID identity protection. You need to know that it does require a license for this. But it is identity protection is the ability to make sure that only users are authenticating as expected. It gives you the ability to ensure that if there's a unusual login activity, you can be alerted on it. You can also potentially block it, or you can require MFA, or you can require user to reset. So those are some things you can do to control how they log in. There's also the option of implementing self-service password reset. You need to understand that there's certain groupings of options there that you can require them to do MFA, you can require them to have a certain set of questions, certain options around that. Again, licensing requirements here. Implementing conditional access using, including MFA. Again, you can require that if they're from a trusted space or trusted IPs, that they have to authenticate via MFA, or if they're not from those areas, they have to require MFA. You can set up to where if it's entrusted, they require MFA, but if it's not entrusted, you won't even allow it to log in. Might ask why you'd want to do that, but a lot of times these are maybe for management keys, somebody who has a privileged access, and you don't want them to be able to log in unless they're in one of your trusted spaces. Be a little cautious about that, because if you have a break glass, the reason why you have to break glass to have access to it is because your building burned down and nobody has the logins for it. If that IP was associated with it, then that could potentially cause you problems. However, it's a potential way to make sure that people don't use that one outside and from another country that you're not particularly a member of. So there are different options around that for conditional access. You can also do conditional access by applications. So there's lots of different options there around the configuration of the conditional access. You can also configure certain users to only use MFA if you wanted. When you first set up MFA, a lot of times you don't want to put it out to the entire environment. So you can do it by groups, or you can do it by individual user. And then you can continue to add users to that as you want to roll it out. So keep that in mind, that you don't actually have to do it to everybody in the environment. You can only do a few. You can set up fraud alerts. So again, like we have our monitoring environment in our security center, we can set up alerts just in that same setup. If we see the signal being that we have a fraudulent authentication, we can set up alerts around that. You can set up some bypass options so that if there's a particular instance where you need somebody to temporarily be able to get past MFA, because maybe they've lost their phone or it's gotten destroyed or something, and you've been able to authenticate them either in person or through some other administrative process. You can temporarily allow an account to bypass MFA requirements. I mentioned before the trusted IPs. The idea is that you can set up a group of IPs that are identified and saying, hey, these are the ones that I know of. They're secured. A lot of times you'll set these up for like the NAT for your company environment. All your different offices are usually coming across as only 1 or 2 IPs if you have a small organization, or at least a few dozen, depending on your environment, maybe a few hundred. Those can be trusted IPs. You can also set up individual groups of those IPs and say, here are US IPs, here's our North American IPs, here's our European IPs, those types of things. You can set up additional groups and you can apply the rules to those, so you can have conditional access based around that. There are also multiple ways you can do verifications for doing the password resets. There's the SMS through your phone. You can also do an application through a phone. You can also do voice verification, and you can also do questions where you have a bank of questions that they can choose from, or they can specify their own as an option, and how many questions they have to do for that. So there's those different ways that you can verify the users for doing those actions. The idea too of implementing and managing guest accounts. And a lot of times people forget that the guest accounts are what also called B2B. When you set up an Azure B2B user, that is a guest account. The idea behind a guest account is that there's another company, another organization that's utilizing Azure AD, and you want to grant them the ability to utilize some resources in your environment. You then invite that user in as a guest, and then that object is now within your Azure AD as a guest user that you can assign accounts to. You can assign permissions to, rather. You can assign it either RBAC levels, or you can put them into groups. You can treat them as a user. The nice thing about a guest is that you don't have to maintain the user's login and the user password. That's maintained in their own environment. You can still set up conditional access, though, to where you can require MFA and other things for that account. It makes it much easier to manage and control those users. When you're dealing with Azure Active Directory, the entities and namespace where all those users are kept together is called a tenant. The Azure AD tenant is also where you contain the users, the groups, the custom domains, the applications, the enterprise. All those things are kept within Azure AD tenant. You can have multiple subscriptions applied to a single tenant. However, one subscription cannot apply to multiple different tenants. Okay. There's also a lot of permissions around the Azure Active Directory tenants. One of the main ones being global admin. The global admin in Azure Active Directory is basically the enterprise admin, the God level access for that Azure AD. And you may find in particular instances that you need to have elevated access for some other application. The global admin has a very special attribute when it's dealing with Azure subscriptions. There is the ability for the global admin to grant themselves access to all subscriptions that are associated with that tenant. That global admin is granted a user access administration role in all subscriptions if they choose to enable that. When they enable that, it gives them the ability to change permissions on any subscription. This is obviously a very high-level security access. This needs to be a type of break glass for any subscription that's managing your Azure Active Directories, or Azure subscriptions. So it's a global admin in the Azure AD. So in that instance, sometimes you need to have multiple different tenants. This is what they call multiple different directories, because an Azure Active Directory is your different Azure AD tenants. So sometimes a common case is that Office 365, for some tasks, especially legacy, you need to have global admin to achieve certain level access in your Office 365 environment. It's also where all your users were logging in, and that's where they already had identity set up. So frequently, sometimes you would set up an Azure Active Directory tenant for your Azure subscriptions that would then manage it, and then you would bring people across from your Office 365 Azure AD tenant as guests into the Azure AD tenant that was managing all your Azure subscriptions. Therefore, if Office 365 needed a global admin, that was fine. They'd log in with it, and they'd have global admin in their space. And then you could bring across users who need to manage your Azure portal as guests, and whoever was a global admin in the other tenant had no access in your space, unless of course granted it. So you need to have the idea of multiple different tenants. The big downside to the multiple tenants is that you can only have your custom domain in one tenant. You cannot have the custom domain in two different tenants. Custom domains are globally unique throughout the entire Azure space. Once you verify the custom domain in one tenant, it cannot be used in another tenant until it's completely removed. Okay. So that's the downside of multiple tenants. Obviously, there's management headaches along with it too, because you have users in multiple different locations. So minimize the number of directories, but understand you can manage those directories. You can also move between those different directories. If you're a guest user, you can go into the Azure portal and you can select the different tenants from the little directory tab and choose the different tenants to work in the different ones. So if you're managing them for whatever reason, whether it be a cloud solution provider or consulting in space, you can move between those tenants to get access to the different subscriptions. And then finally, managing hybrid identities. Hybrid identity is the idea of if you have an identity that's in Azure cloud only, then it's only being able to be used in anything in the cloud space, whether it be platform as service resources in Azure or Office 365 or partner software service or some other space. Those are all going to be available only on the internet. However, most companies have an Active Directory presence on premise. In those particular instances, sometimes you want to use the same login that you use on premise that you would for the cloud. We can replicate those on-premise identities up to Azure using Azure AD Connect. When we use Azure AD Connect, it's going to try and join those together, usually by user principal name. You can change a few of the options in the synchronization, but usually it's based on login name. You can also key it off of email or a few other attributes if you want to customize it. But the idea here being is that you synchronize a user from on-premise up to Azure, and then whatever username details are on premise, whether it be the first name, last name, email, manager, groups, those sorts of things are replicated across Azure AD Connect. And so that premise is now available in Azure AD. At that point in time, it becomes a hybrid identity. Okay. When you're replicating the hybrid identities, there's a few different options, especially around passwords. They're very key when setting them up as an architect. You can do a simple password hash sync. So that people may think that they're syncing your password, but you're syncing a hash. This hash is stored in your Active Directory, and then that hash is what's replicated up in Azure. We're not actually replicating the password itself, but it is a hash. And that is something that could be potentially brute forced if somebody were able to access it. But the idea here is that is just a hash of the password, not the actual password. Some environments, that's not appropriate to even have a hash stored outside of their space, and it needs to be kept on premise. There are two options that you have then if that's the type of authentication they want to do, where no password is kept in Azure. In that particular instance, you can do what they call a pass-through authentication, or PTA. In a pass-through authentication, you actually have an agent that is running on your machines in your on-premise environment that can talk to those domain controllers. We recommend at least 3 of these agents. Now, one of them can be your Azure AD Connect, but you want to have at least 2, and this is somewhat for load balancing, but really it's for highly available. Because in the event that there is no pass-through agent available to Azure, nobody will be able to authenticate to Azure. So the pass-through authentication is required for any, if you've configured that, you have to have a pass-through agent available. Otherwise, people will not be able to authenticate to Azure. Okay. The final way to authenticate is what's called federated authentication. You also hear ADFS, which stands for Active Directory Federation Services. That's your federated authentication. In that instance, what you're actually having to do is the user will, when they put their username into Azure, they'll be redirected to your ADFS servers for authentication. And ADF servers are servers that you host. There is a minimum of 4 servers set up when you're setting up ADFS. So for the hybrid authentication for federated, you have to have the Azure AD Connect server, which is replicating it. Again, you can only have one per forest, or excuse me, one per Azure AD tenant, one Azure AD Connect. Okay. And then you have your ADFS, where you have your 2 web interfaces for high availability, and then your 2 federation servers that are actually doing your authentication and databases, again, for high availability. And those are talking to domain controllers. So you have to have at least 5 servers. Most environments, because of ADFS, have to be close together for the replication. You'll find that you have another ADFS cluster in another region for high availability and data and disaster recovery. So it's starting to get very complex very quickly. Most environments, if you do not already have ADFS in place, you usually will not deploy ADFS, because it is, lots of additional overhead and is, again, key for the environment. If your ADFS system is down and you've set up a federated authentication, you will not be able to authenticate to Azure at all. Okay. The pass-through authentication is the next option, where if you don't have ADFS in place and you don't have the password stored up there, the pass-through authentication is the next option. But again, you need to have at least 3 servers that are running your Azure AD pass-through authentication option. And then finally, the final option for single sign-on is the password hash authentication, in which case the password hash sync is storing up in Azure AD. In this scenario, if your Azure AD Connect is down, or you've lost communication with your on-premise for whatever reason, because those password hashes are stored in Azure AD, they'll continue to run. I also mentioned briefly your Azure AD Connect, you can only have 1 per tenant. You can set up another one in a standby state. It is a cold standby. It is not going to be replicating. It is not automatic failover. So in the event that your Azure AD Connect goes down, you can go over and spin it up and make it active, but it is a manual process. There are ways to script it, but it is not something that's built into the system to do an automatic failover between them. Azure AD Connect only replicates once every 3 hours. So if it's down, all you're losing is the ability to replicate usernames, passwords, or password changes, or name changes, those sorts of things. Okay. So that was all talking about password syncing and password options around that. On top of that, there's the option of where you can do the self-service reset in Azure. And if you enable users to self-service reset their passwords in Azure portal, and you're synchronizing your password or doing pass-through authentication, you want to enable the password write back option. Because what the password write back does is if they go through the self-service password reset, it'll write them back down to their on-premise environment. Okay. So if you're doing the password hashes, that gives you the ability to change the password in the portal. They can go through all the validation and verification first that they do have the authority to change their password. Then they can change their password, in which case it's sent down to the Active Directory or Azure AD Connect to validate against your domain controller, and then bring it back up. Okay, that's needed for password write back. Okay. There's also the option of configuring single sign-on, which allows you to authenticate across between the environments with the same username and password, so that your on-premise is logging with the same one that you have in Azure. And that is an option for the Azure AD Connect wizard as well. When you're configuring and setting that up, you need to understand what is needed to get that set up. Another key piece of Azure AD Connect is the Azure AD Connect Health. The Azure AD Connect Health is where you are running an agent and get on your local Azure AD Connect server to validate that it's connecting and that's healthy and that we're not having replication problems. This is key when you're setting up Azure AD Connect, because again, if you're not replicating, if you're not monitoring that system on premise, you won't know, and you'll start to have usernames get out of sync. You'll start to have passwords getting out of sync, and you can start to have some real issues here. So Azure AD Connect Health is very important, even if you're just doing a basic password sync hash. It becomes vital when you're doing pass-through authentication. Also on that topic, pass-through authentication, another reason why you'd want to do that is if there's a login policy that you have an Active Directory that is not supported by Azure Active Directory, one of those being like logon hours. If you have something like that that you want to validate, because pass-through authentication is doing the authentication to the domain controller in real time, they are still subject to whatever those policies are for your authentication. So that's another reason why sometimes people do pass-through authentications for something like logon hours to be able to access them. These are some of the labs in the Skill Me Up environment if you're interested in finding out more about these spaces that you can utilize. Implementing the Azure Monitor, the Log Analytics, Storage Explorer. The Storage Explorer is really good for helping you understand how the data is stored and how you can retrieve it. Also using infrastructure as a service is really good for the deployments and understanding how the templates get out there. And then also peering virtual networks. If you had a chance to work with a virtual networking space, that's a good lab for understanding it. So that is the major section around implementing and monitoring Azure infrastructure. Again, that is over half the exam is usually on those sections. The next major section is implement, manage, and security solutions. And these are around managing the workloads in Azure, implementing load balancing and network security, implementing and managing Azure governance solutions, as well as managing security for applications. We're talking about managing the workloads and the security around them in Azure. We want to talk about migrating the workloads using Azure Migrate, as well as implementing the Azure backups for Azure VMs, implementing disaster recovery for not only VMs but our applications, as well as implementing Azure Update. Okay, so when we're talking about migrating workloads using Azure Migrate is not just replicating the servers up and getting them across and moving them over. Azure Migrate actually is around the idea of assessing your existing environment, identifying how they're being utilized today, and what can be replicated across, because Azure Migrate can actually do not only virtual machines, it can also do web apps, it can also do Azure Backup, excuse me, Azure databases. Azure Migrate does not only virtual machines, it also does web apps and also does database replication as well. The Azure Migrate is the workflow of assessing the existing environment, identifying what it is that's running out there. These usually need to run for at least a couple of weeks so you can get a good idea of what your actual workload is. This is not something a quick wizard you run through and look at your environment and get back in 5 minutes what your workload is. We need to observe the environment for extended period so we can see how it's actually being used, not just a point in time of what it was like. We need to actually see what the growth and usage of that environment is so we can probably assess what type of resources you need in Azure. Once the assessment is complete, you can actually do the replication of that data up in Azure. If it's a virtual machine, we have resources to actually identify, or excuse me, actually replicate those machines in near real time, and you can get those up and going within a matter of minutes. It does take a while to do the first replication and then do continuing replication. If you're familiar with Azure Site Recovery, it's using the same technology if you use Azure. Azure Migrate can integrate with third-party tools, though. Third-party tools can do the assessment. They'll generate the reports and access. You could also do the same tool with different third-party tools to do the actual replication of the virtual machine. That's the actual migration pieces. As you're doing that replication, you're replicating across those virtual machines. You can do replications for VMware. VMware can do agentless or agent-based. The idea behind agentless is that you're talking to the actual VMware vSphere or vCenter controllers, and you're talking to them to get access and do the management and do the replication, so you do not actually have to have anything installed on your virtual machines themselves. Okay. This does require certain access into the vSphere environment. You do have to have access at a low level to read those disks so that you can get those write changes. However, it means that you don't have to have really any authentication into the virtual machine itself. Agent-based migration, however, means that rather than having to have a deep level into the vSphere and the storage on it, you go off and you install agents onto the virtual machines themselves. Those virtual machines then, as they write off to their disk, they're going to write off to a central replication server, your configuration management server, which is called the process server. That process server is going to take those blocks, store them locally on its disk, and then it's going to replicate those up into Azure. Every change that's going off to those virtual machines are going to have to hit the virtual machine, and then they'll hit the process server. That process server is then going to spool those and send those up. The process servers usually need to have at least 600 gigabytes of storage at least. You also need to get that first copy of those virtual machines across. And if you have a virtual machine that's really big, you're going to have to replicate all those blocks, even if they haven't changed in a long time, to the process server, and then the process server is going to have to send up to Azure. Also, if you have virtual machines that are doing a lot of data change, an example sometimes is high-speed or heavy SQL servers, where you're constantly writing blocks out to the virtual machine or out to the disk. If the rate of change is exceeding the bandwidth that's going to be available for us to replicate across, that's not going to be viable for you to do replication migration this way. There are other technologies around that, and that's why there's this particular Azure Migrate for migrating databases. So you need to keep that in mind if you're doing some sort of replication around that. When it comes time also to configure those for the migration, they'll take in the input from their assessment reports to identify the size of the virtual machines that you're going to need. The big thing here is that if you have virtual machines on premise, sometimes they'll oversubscribe that virtual machine CPU needs. Sometimes there was just an abundance of resources and they'll oversize that virtual machine. If you move that up to Azure with that exact same size, you may find you're spending more than what you need to. So the assessment helps you identify that, okay, this one was oversized, so we'll go ahead and scale that back down to a more appropriate size based on what the load of the virtual machine was. That assessment determined that, and then it can feed that into the migration piece that's actually going to replicate and spin up that VM, so it can help you identify the size for that. The other piece that assessments will do will help you identify virtual machines that need to move together. If you have a large environment that's encompassing hundreds of virtual machines, there may be certain ones that need to move together, and you may not be able to do a whole switch over in one night. In that particular case, the assessments can help you identify, okay, these 50 machines are all talking together, they're all doing an application solution, so you probably need to move those together. That's something else that would be provided by the assessments. Once it's up and replicated into there, there's then the additional workflow of following up, making sure those machines are secured, making sure they've been patched, and then continuing to assess the cost and load on the systems, and that's all part of the Azure Migrate workflow process. Once you have it up and running in Azure, or you have machines even on premise that you want to make sure are available in the event of disaster, there's the Azure backup option. Now the Azure backups, if you're running a virtual machine in Azure, it's a simple option of going in, configuring the backup, saying, hey, I want to go ahead and back this up with this backup vault. You can set up policies to say how long you want to retain that data. So you can do dailies that are kept for a few weeks. You could do weeklies that are kept for a couple of months. Do monthlies that maybe are kept for maybe a few months, maybe a year. Then you have yearlies that are kept for multiple years. And you set those all up in backup policies. The built-in Azure backup for VMs will only back up VMs once per day. Some environments, that's not enough. Also on-premise, you may want to back up differently, or you may want to do your backups and have them stored in Azure. Both those solutions you can use an Azure Backup Server, ABS. The Azure Backup Server allows you to configure more granular controls. It also will take the backup from whatever machine you're backing up, whether it be on-premise or in Azure. It will then replicate that into Vault in Azure so you can store the long-term retention in the Azure Vault. When you do a backup via the Azure Backup Server, is basically doing synthetic fulls. You do one full backup and then you're doing incrementals after that point. The incrementals are then grabbing all those data that changes over that time frame. When you have a backup of a file server, and there may be just individual servers or individual files you want to restore, you can choose the option to restore just the individual files back, rather than have to restore the entire virtual machine. If you have a problem with the virtual machine, you need to fully recover it. You can either restore directly on top of the existing virtual machine in Azure, or you can choose to restore to another virtual machine. Backups are really good for covering from a virtual machine that has a particular failure or was maybe an issue that was deleted a long time ago or corrupted, and so you need to go back to a further point in time, as far as like weeks or potentially even months back in time. However, they do not give you a really granular control. They can take a while to do a full recovery from. Some resource can take hours, depending on the size of the virtual machine you need to do. In those particular cases, that virtual machine may not be available in the event of a major issue. Disaster recovery is available in Azure in multiple different ways, depending on your solution. For virtual machines, there's a tool called Azure Site Recovery. Azure Site Recovery is the same type of thing that was used for Azure Migrate, in the sense that we're replicating the data from a virtual machine in Azure in one region, and we're replicating it to another region. Traditionally, you would try and put them into your paired region for Azure. If you're not familiar with paired regions, you can go look those up real quick. You don't have to memorize what the paired regions are, but you do need to know what they're there for. The idea behind a paired region is that you have another region that's going to have the same version of content, the same services available in similar capacity between the two environments, so that in the event of the main region goes down, if it's paired region, it's available, assuming it's not global catastrophe. But anyways, that major region fails over to the other region, it'll have the exact same versions of services. It'll also have the same capacity, so you'll be able to run your services over there. It is possible, though, to replicate to an entirely different region that's not the paired region. However, you need to make sure it does support whatever services you need to run, because not all regions have all the same services. It does allow you to replicate to different geographical regions. You can go from the US to Europe if you need to, but there is additional costs, obviously, around those types of ideas. So usually you're staying within your geographical region. One key note is that you are using the same site recovery vault that you would use for backups for site recovery, but it does not have to be the same recovery vault you're using for your backups. Frequently, they are different. One of the main reasons why is because the Azure Site Recovery cannot be in the same region as your virtual machine that you're making sure is protected for disaster recovery. This is to ensure that in that region, the virtual machine is lost for some reason. The recovery vault has all the details as far as the size of the virtual machine, the configuration details, and the snapshot information. If that recovery vault were in the same region as a virtual machine, it would be lost. You wouldn't be able to recover that virtual machine, so therefore it's in the other region. Disaster recovery with Azure Site Recovery also gives you the option to do test failovers. It is recommended you do test failovers at least once every 6 months. What test failover allows you to do is it takes a point-in-time snapshot of the virtual machine disk that's being replicated and spins up a virtual machine in your failover region that is an exact copy of your production VM. You're only charged for that compute and storage time while that virtual machine is running. You're charged for this storage as long as it exists. When you're done doing your test failover, you tell it to do a cleanup test failover, and the Azure Site Recovery will then clean up all those resources it created and get rid of it. Okay. During the time of the test failover, replication continues to happen on your primary system, but it will. But the test recovery will be stuck at that point in time when it was created. Site recovery only has replications back 24 hours or 72 if you're using standard storage. It is not intended for long-term retention. It is only for disaster recovery. You will have multiple snapshots in that time period. The recovery points are frequently around 5 or 10 minutes as far as when you can recover it. But they only go back 24 or 72 hours. This is to limit the amount of storage that they take up. Extending beyond that is something that you need to be using for backups. Azure Site Recovery is only intended to be short-term retention to ensure that we have very frequent copies and immediately available. In addition to doing disaster recovery, you need to make sure you understand the ideas behind Azure Update Management. Azure Update Management uses Azure automation processes to actually manage the updates of not only Windows machines, but also Linux machines. This allows you to patch and control those machines and ensure that they're being updated on a regular basis. It's a built-in function of Azure automation. It's available to all virtual machines in your space. Something that you need to understand the ideas behind and being able to utilize the Azure Update or Azure Automation books in order to update your virtual machines. In addition to doing managing the workloads of the virtual machines themselves, you need to understand the idea behind load balancing and network security. We're talking about a load balancer. This is an actual object within Azure that is then talking to the virtual machines that on the back end. It can be either public facing or an internal load balancer. The internal load balancer is only going to be a private address space, where the external is going to be a public space. The idea too is that a load balancer can load balance either UDP or TCP protocol of any kind. It doesn't really matter what's on the back end. It just looks to see whether or not the port's up or down. You can do a check based on health probe based on HTTP as well, just to see if the app is there, but it will transfer or direct to either traffic. It does not do any inspection of the packet other than to say that this is going to this port. You also need to know about the couple different tiers. You have both the basic and the standard tiers, so about those. In addition to the load balancer, there's also the application gateway. The application gateway is a resource in Azure as well that does layer 7 load balancing. It is HTTP only. It also does HTTPS, but it's just HTTP based traffic. You cannot do any other protocol except for something that is wrapped in HTTP. It does also have the added feature of or optional feature of web application firewall. The way an application gateway is going to work is that a request is going to come into the application gateway. It's going to take that HTTP request, evaluate it, look at its header, look at what the host name is, look at what the path is, and use that to determine what's going to route it to on the back end. The back end can either be a virtual machine, it can be a website, it can be a external URL. It does not necessarily have to be something in the Azure space, but it has to be a web-based scenario. The web application firewall is available in the application gateway as well as the front door. The idea behind the web application firewall is as a security system using OSCP rules to look and see if it's one of the most common scenarios of vulnerability. It is, you have the option to enable or disable those rules, but you cannot customize those rules. You cannot put in your own rules. It is a well-defined known attack vector protection. This is the same for both the front door as well as the application gateway version of it. In addition to the application gateway and the application firewall, there is the actual Azure firewall itself. Now, the Azure firewall is a resource in Azure that allows you to control the traffic at a protocol level. It is better at dealing with the actual protocols than just the plain NSGs that are in the virtual network gateway or virtual networks. If you're familiar with NSGs, those are just a basic source, destination, IPs, and ports, and we're just allowing or disallowing based on those scenarios. The Azure firewalls themselves allow you to do that, as well as doing application filtering and controls around that, as well as threat intelligence, to where if there's a threat that's identified based on machine learning or other environments in other spaces in Azure, it'll allow the alerting of that traffic or actual active blocking of that traffic. Those are really the only options for threat intelligence in the Azure firewall. You can either alert on that threat intelligence or you can block the traffic, block on the intelligence. New as of January 27th is Azure Firewall Manager. This is something that has been just added. It was the only update that was done to AZ 303 on January 27th, which was the last update for the AZ 303 as of this recording. The Azure Firewall Manager basically gives you the central management of the Azure Firewall space. It allows you to do centralized policies, and it's based around either doing a virtual network hub or a virtual WAN hub. If you haven't worked with virtual WANs before, the idea behind a virtual WAN is that you basically define a space in Azure, a hub that the remote sites connect into, similar to a virtual network gateway, just kind of eases the management of those. And it also allows all the peers to be able to talk to each other. So if you have multiple sites, you have multiple different offices that are going to need to connect to Azure, they can all connect to Azure, and then you can also allow all those different sites to talk to each other. And the nice advantage of virtual WAN is that basically you just set up those connections to come into the virtual WAN, and then you just connect your virtual networks to that as if you would do for a peering type of network and connect those into there. The Azure Firewall Manager allows you then to manage a firewall that is attached to that virtual hub or a virtual network that's set up as a hub and spoke where an Azure firewall has been deployed. Azure Firewall Manager will also allow you to manage third-party firewalls through policies of select vendor set only in a virtual hub. Now, that's one thing that you need to make sure is very clear, is that there's the virtual WAN virtual hub, but then there's a hub virtual network. A hub virtual network is a virtual network that has been created in your space that other virtual networks peer to. A virtual hub is something created with a virtual WAN. Okay, third-party firewalls for the Firewall Manager are only manageable through the virtual hub, which is the virtual WAN. That's the only place that you can do the third-party WAN management, or third-party firewall management. You can manage an Azure firewall that is in a virtual network that then other virtual networks connect to as a hub. Okay. Basically, you set up the policies that you want to configure at the Firewall Manager, and then you can distribute those to the Azure firewalls as you need. This is to compete a lot of times with third-party management tools such as Palo Alto's, Cisco's, Juniper's. All of those have they would have management tools. to manage multiple different firewalls simultaneously. Firewall Manager gives you the same type of configuration where you can have all of your firewalls managed through one central policy setting. In addition to the Azure Firewall Manager is the Azure Front Door Service. I mentioned a little bit with the Azure Web Application Firewall. The idea behind the Front Door Service is that you're doing web traffic similar to what you would do with a application gateway, or the Front Door Service is global, whereas an application gateway is only for a particular region. So just the East US, just Germany, just Southeast Asia, whatever region the application gateway is deployed in, it's only servicing pieces within that region. The front door service is something that you can configure to go across the entire globe. So it's not something that just has to be local. Also, the front door service also encompasses CDN, content delivery networks, for caching and forwarding of the data, as well as some URLs and rewrites and management that way. But it does encompass the same web application firewall that you would see in the application gateway. So again, the difference between those is the front door service is global, the application gateway is regional. The traffic manager is similar to the front door service, and that is a global setup. However, traffic manager just redirects basically DNS queries. It's looking to see on the back end which endpoint is up, and then it's giving a CNAME record to the client to whichever resource it needs to be connecting to. So the traffic manager allows you to route traffic based on round robining, priority, or simple up-down, or you can also look to see where the client is coming from and send them to a locally present endpoint. So if you know that a client is coming from the East US, you can configure that in your traffic manager. If they're coming from the US and you want them to be able to come to a US resource, you can do that. But if they're coming from Europe, you maybe want them to go to a Europe resource, and so you can configure that as your routing role for your traffic manager. So whereas front door is the global version of application gateway, in a lot of ways you can think of the traffic manager as the global version of load balancer, in the sense of traffic manager is going to be routing you between different regions, whereas a load balancer is going to be doing resources locally. Neither one of those worry about what the protocol is on the back end. They're just basically allowing you to do whatever type of routing you need to for whatever protocol you're using. They're protocol agnostic, whereas web application firewall and front door are web only. So traffic manager, front door global, web application gateway and load balancer are local. Load balancer and traffic manager any protocol. Web application gateway and front door are web only. I mentioned before the Azure firewall, you have network security groups, but you also have application security groups. Again, network security groups are usually you have a source and destination IP and source and destination ports, and you allow or disallow. You can define certain services within the network security group. So if you know that it's a Azure load balancer that you want to allow, or if it's a Windows Update service or SQL Server, there's IPs around those, and those are published services that are available in network security groups. Similarly, application security groups allow you to define the same type of thing for your application. You can associate your application security groups to your virtual machines. So that you can say, for instance, you have a web tier that's running an application, and then you have it talking to a backend middle tier, and that middle tier is talking to a backend SQL. You can identify the applications that are running your web tier by an application security group, and then you can define your middle tier by using an application group called middle tier or mid tier or something like that. You have a database backend running something like DB application security groups. You can then, in your network security group, rather than specifying IP addresses of all those different levels, you just put in what the application security group is. Application security groups are region specific, so you cannot do the applications to go between a whole bunch of different regions. It is something contained within just a specific region. Also, if you traverse across a network peering, that application security group information is not maintained, so it's just within that virtual network. Okay, so this is really defined as an easier way to keep track of the IP addresses. So every time you add a virtual machine, you're not having to update your, go and update your NSGs. You're not also having to set up your NSGs by entire subnets or IP ranges. You can just set them up by being tagged by using this application. So the idea here being, again, application security groups, identify what your application is so you don't have to do a range of IPs and manually change IPs and NSGs. And that's just an easier way to tag things so they can be more dynamic. A common scenario where sometimes application security groups are used is that the network security team may be saying that the network security group rules, but they can't keep track of all the different applications. And you want to have something more secure than just individual subnets, which is what we would have to do in the past. Because IPs and Azure chain or dynamic, or the network security group would have to go in and constantly change fixed IP addresses. By using application security groups, you can separate out those roles where the network security group defines, okay, if your web tier can talk to your app tier can talk to your database tier, and they can set up those rules in the NSG. Your deployment teams, your virtual machine teams can then go in and say, okay, this virtual machine is running the web app. This virtual machines are in the middle tier, and this virtual machines are in the SQL tier. And they didn't have to initially worry about communicating the IPs between each other. Finally, there's the Bastion that was created. If you've ever worked with a high security environment, a lot of times there's a need to have something like a jump box, or you want to have some sort of access to those virtual machines that are running in Azure without having to have a public IP on them. What the Bastion allows you to do is it creates a resource in Azure that is connected to your virtual network. You usually can then authenticate to the portal and access a virtual machine interface of that machine and connect to your actual backend virtual machine. It can do this either over RDP or SSH. So if you have a Linux machine, you can connect over SSH. If you have a Windows machine, you can connect over RDP. That's just between the Bastion and the virtual machine itself. Coming from Bastion to whoever the end user administration is always going to be over HTTPS. It's a web-based interface that gives you access to it. You cannot copy files across the Bastion interface if you use something like RDP, where you're used to copying files across. There is not the ability to do full copy. You can copy limited amounts of text, but you cannot copy like an entire file like you would in RDP. Bastion also requires a dedicated subnet for it to do the Bastion hosts in. That must be configured as part of the virtual network. This satisfies the ability of being able to isolate virtual machines such as for PCI environments without having to initially have direct access to the machines, but still be able to manage them. This way you're going to have a VPN connection or any other type of remote connection. You just have a single Bastion host and that VNet and be able to access it. You cannot use Bastions to connect to virtual machines off of the VNet that's associated with. If you need to have two different VNets that you need to connect to the Bastion hosts, then you need to have two different Bastions. When you're doing management in Azure, you need to make sure that you're keeping track of the Azure governance as well. This is the big major topic. You need to understand the idea behind hierarchical structures, including management groups. If you're not familiar with management groups, basically they're an organizational structure above subscriptions. They can go up to 6 tiers deep. You can have a very wide set of management groups, but it is a tree structure that can go 6 levels down. There is always a root management group that is created by your account when you first create your first subscription. All subscriptions default to that root management group. You can then create management groups underneath that one, and you can move subscriptions underneath it. Management groups can only have policies and RBAC rights assigned to them. Those then traverse down the tree. So if you set a policy at your root management group, it will go across everything in your environment. Policies are a deny-based structure. So if you denied somebody something at the root level of your management group, it's going to be denied across your entire space. And RBACs, commercially are allowed rights. So if you allowed somebody access at your management group, it's going to be allowed across your entire space. A lot of times people use management groups for something like geographical management. Maybe you have a particular group that has to manage North America, and a different group that has to manage Europe, and a different group that has to manage Asia or something. Then you would set up those 3 different management groups, and you could then put your subscriptions underneath it. Another common practice is to use management groups for like production, and then another one for dev. This ensures that there's much more restriction put on anything that's under the production management group, and then you can have a little bit more leeway in maybe your development and maybe even your test environments, so that you can maybe have a little bit more broader access, but ensures that the production subscriptions are all highly secured. Subscriptions and resource groups are the base environment for any resources in Azure. You can think of the subscription as a management zone where everybody, or the resources and management is all contained within that subscription. Resource groups are then a way to manage those resources either by access or by lifecycle or by security. So when you create a resource group, those resources inside of it are just a management aspect of it. If you grant rights at the resource group level, those resources inherit those resource group permissions, and same thing for policies, so that all the resources within that resource group have access to it. You can have resources talk to other resources and other resource groups. They do not have to all be in the same resource group in order to communicate or use each other's functions. Also, you can have resources in different subscriptions talk to each other. It's a common practice where there may be a particular application that's done in a particular subscription for either management or cost control, and it accesses resources in another subscription. That is actually fully usable. In fact, if they're within the same tenant, they can authenticate directly with Azure AD spaces. You need to understand how to do assigning RBAC roles as well as creating custom roles. If you're not familiar with the term RBAC, that's role-based access control. You'll see that a lot. You also need to know that it is under the access control, or IAM, under the interface for the Azure portal. If you haven't seen that yet, make sure when you look at the portal, you look at the access control IAM. You will never see RBAC in Azure portal itself. You will always see the roles and the role access. You need to understand that when you're the RBAC roles are define what people can access, and there can be what they're allowed to, and there can be things that are not included in the role. However, the roles themselves do not actually deny anybody access to resources. There will be things that's not included in a role, but that just means it's not in that particular role. If they're assigned another role that does have it, they'd be granted that access. Okay. The idea behind a role is that you're doing least privilege access for a particular purpose. Multiple users can be assigned the same role. You can also assign roles to groups. Okay. So that's another key thing to keep in mind, is that you have the role that defines what is accessed. You have the user group, the object, the identity that would be assigned a role, and then you have the assignment itself. The assignment defines the scope of where the role is being assigned, the user who it's being assigned to, and the role itself. Those 3 aspects are contained within an assignment: the scope, the user, and the role. Those 3 together make up the assignment. You can also create custom RBAC roles. Custom RBAC role is basically a role that you've deemed that you have some purpose that needs to be a collection of the roles that are defined. You need to understand how actual role is set up. If you've never looked at a role in an environment, it's important to know what those look like. Pulling those up real quick. So, when you're working with those roles, they're defining by JSON structure exactly like you would a template. It's that same type of format, but it's focused specifically around the roles and the access that they would be assigned. You can access the roles by going to the access control area. Again, I am, and clicking on the roles. And lists off all those existing roles. You'll notice the ones that are listed here built in. There are several roles that are used for common access in Azure Space that they have predefined already, so you don't necessarily have to keep track of them. If there is a built-in role, unless there is some compelling reason that you need to create a custom role for what's already there, try and use the built-in roles if you can. Try and combine multiple ones together if you need to have somebody that is not only a blob delegator but also a queue reader. You can assign both of those roles to that person. You don't have to go out and create a custom one that encompasses the same things between them. You can assign multiple ones together. You may have somebody who's a virtual machine contributor, but they're also doing the network management pieces as well. They have a network contributor, so they can do both of those. These are all the existing built-in roles, just to give you an idea of what they look like. This is listing off all the different providers that provide off the different permissions for a role. Then within the role, here's all the different options out they listed out there. That's just the graphical interface of what they look like. What this is actually defined in on the back end. Anyways. Sorry. Sorry about that. So you're doing in the back end, you can add in a custom role. You can add in the permissions directly in here. You can put in common ones, and this is what you might find a lot of times in the interface. If you know particular ones you're going to be looking for, you can also summarize them all together. There's also, we've talked about the data plane versus action plane. Actions are the management, data actions are the actual data management, such as when you're looking at storage, the file permissions around that. This is what the JSON ends up looking like. So for instance, if you're working with a contributor or a storage account that we referenced, If you want to grant everything under the storage space, you can grant all those. Then data access, you have the file shares, and you have the reads and writes. And notice these are always permissions are done by the provider, the type of resource, and then whatever subtype line behind it. In this case, file services, file shares, and the files below it. You can also have the blobs. You can have the tags of those blobs, and you can also have queues and the messages behind them. Okay. So if we granted all access to the storage account here, if you look at the JSON back for that, you notice they list out the ones explicitly here. However, the way this is normally actually written for most environments, so if you said you want to do everything in the storage account, you can actually say, I want to do all of this. Oh, you can actually edit the view. Sorry about that. In here. And that would give you everything under your storage account. Same type of thing if you want to do just the particular settings for everything for Bing accounts, for example. You could just put an asterisk there. You can also say for any action underneath it, for anything under your list of keys, you could just put an asterisk as well in that space. If you wanted to give everybody the access to do all access, particular environment, this would be the same as giving somebody owner rights to it, where they basically have the ability to do all actions. Because I could view it, but the asterisk is what's assigned when you're doing an owner ability. So that's all environments. You can also then exclude it, certain things. So, for instance, the main difference between the owner and contributor is the ability to make permission changes, which is contained under Microsoft authorization. Okay. If you don't want them to be able to write, then you can deny them the ability to be able to write in those particular environments. You'll notice in GUI, it doesn't give you all the different options in there. So for instance, if I don't want them to be able to do any type of write in the Microsoft authorization space, edit again, sorry. Basically what this is saying is it gives them the ability to make any change in the environment. However, they cannot make any writes to the anything under the authorization. This is the type of thing that you would do with a contributor role. This is a very simple form, and I wouldn't do this because you would want to do contributor. Also, a lot of times you'll notice I'm doing this through the GUI, but this is normally something where you'd probably do it through a command line, so you can keep track of the JSON. But this just gives you the options of what it looks like in the GUI interface, so you can flip between the different views and see what it looks like. Okay. The other big thing on a custom role is the actual assignable scope. In this particular case, just this particular subscription is the one that's allowed to. You could put in multiple different subscriptions in the environment. If you wanted to be assigned to the root, then it would be assignable to just the root. However, you would then need to make sure that it is in your management scope so that you could be able to change it. You also notice I don't have a role name because I haven't defined a role name out here. So to there. A lot of times what you would actually be doing is calling from existing ones. So for instance, if we wanted to start with something like the storage account, sorry, there's a lot of built-in roles. You can be able just to grab a simple role there and be able to start from that, so you don't have to start from completely blank. Okay. So. You also need to keep the understanding of configuring the management access to Azure as far as assigning rights to Azure itself, the subscriptions, the roles in there. You need to be able to understand the effective permissions, because again, if you assign somebody a right at the subscription level and it's very limited, you can give them more expanded access at a virtual machine. And when you're assigning RBAC roles to it, they're all additive. So if you give somebody owner rights at the subscription level, they'll have owner rights to every resource in that subscription, even if you only give them reader rights to another one. There is no deny roles except in blueprints. It's a very special case. Most in permissions, 99% of your permissions are all going to be a summation of your allow, so it is minimum rights needed. So if you need them just to manage a virtual machine, and that one virtual machine is the only thing they manage, you give them rights and the resources to that virtual machine, and that's it. You don't have to give them rights to the resource group. You don't have to give them rights to the portal, or to the subscription, rather. You give them rights to that virtual machine, they can then access that virtual machine. You also need to be able to set up access reviews around those. The big thing you need to understand about policies is that they are restrictions. Whereas the roles, we have the actions that we're allowing and we can exclude certain actions from it. Policies are basically, you're saying that if they do not match a certain criteria, deny them or perform an action. A common scenario of policies is that you may want to set it up to where they can only deploy to certain regions. You can set up a policy. It will then look at what region they're attempting to deploy it to, and if it isn't in the configured list of the policy assignment to say, hey, this isn't in the allowed region, it will deny the ability to deploy that virtual machine. However, policies will not make any change to an existing system that's already deployed. If you've already deployed things to EastUS and you create a policy that says everything must be deployed to EastUS 2, and you assign that policy to it, those existing resources will not be removed, destroyed, stopped at all. What will happen is that in your report for your policy is that you'll see some that are not compliant with that policy. Okay. However, anything created after the point of when that policy was assigned, they would have to be in that EastUS 2 region. Okay. If you go through the deployment and the policy validation fails, you will not even create that policy. If you want to go do the create, you'll notice a lot of times when you go through that, the last step is validating. What it's actually doing is validating against policies. At that point in time, if anything in that deployment does not match a policy, it'll deny it right there, and that won't let you hit that create button. This is the same also for doing CLI, REST API, or PowerShell. If you try to do a deployment, it's going to upload that deployment, it's going to attempt to do it, and it's going to try and validate it. And if it doesn't pass validation of the policy, it won't let the deployment start. Okay. Policies can be grouped together into initiatives. All an initiative is a group of policy definitions. And just like you have roles with role definitions, you have policies with their policy definitions, and you have roles that are assigned to a scope. You have policies that are assigned to a scope. So you can have a big long list of policies that are out there, but unless they have been assigned, they're not doing anything. And then when you assign them, you can assign them to a scope. That scope can be a management group, it can be a subscription, it can be a resource group. It can even be a resource. That can be whatever scope you're at. Then finally, you have blueprints. Blueprints are a little bit of a bigger beast than policies. What blueprints actually are is that they're taking the templates that you have for deployment, they're taking the policies that you have for adherence, and then they're also taking roles and putting in them as artifacts within your blueprint, and we're putting those all together as one object, as a blueprint. You can then deploy those blueprints to a subscription, and you deploy them to a subscription at that subscription level. You can define in your artifact of your blueprints that you want to have certain resource groups inside of it. You can also configure parameters for blueprints, just like you can policies and templates, to have dynamic changes. But whenever a policy is configured, it includes resources, roles, resource groups, policies, and they are then deployed out to a subscription. Blueprints have their running version, or their latest version. They have the version that you're editing. They can also have previous versions. So you can go out and create a blueprint. You can assign whatever version you want. So, like version 1, version 2, version 3. You can define it however you want to. You could have version blue, version purple, version green, if that made sense to y'all. But granted, V1, V2, V3 is the convention. That's really what you should be doing for best practice. So you have those different versions, and you can go and see which blueprints have been assigned to which subscriptions. And you can see that version 1 of this blueprint was assigned to a particular subscription. If you make a change to that blueprint, what's been deployed out to that subscription does not change unless you go to that assignment of that blueprint and update it. If you update it, it goes to the current version or whichever version you choose. Mentioned before, you don't have any denies for roles. The one exception is a blueprint, because what you can do with a blueprint is you can set it up to where resources that are deployed as part of that blueprint are read-only, or cannot be changed, or just cannot be deleted. Okay. So if they're read-only or can't be deleted. If they can't be deleted, somebody can go in there and they can make changes to the resources, they just can't delete them. If it's read-only, nobody can go in there and make a change to that resource at all. Again, nobody can make that change. Even an owner of a subscription, if you say read-only, anything that's deployed as part of that blueprint, that owner cannot go in and directly change. Now, being an owner of a subscription, they have the ability to go in and remove the assignment of that blueprint, so they could then effectively remove it. But if you had an owner of a resource group and you assigned a blueprint at the root of the subscription, and they were an owner of the resource group, while they could change permissions on the resource group all they want, if there's something that was deployed as part of the blueprint, they would not be able to make a change to it at all if it were read-only. Okay, and this is put in the deny assignments of it. This is the only way that you can put a deny into Azure is with this blueprint. Okay. The only way to remove a deny from a blueprint is to remove the assignment of that blueprint, or that resource falls out of scope of that assignment, of that blueprint rather. The way things fall out of scope of a blueprint is that if you have a blueprint and you have all those artifacts defined in there, if you remove one of those artifacts and then go update that deployment, that artifact that was a part of that blueprint is not deleted. That resource, that role, whatever, that's not deleted. It remains in that subscription and still exists. Just because it fell out of that blueprint, we didn't want to destroy it. However, anything that was locked, any read-only access or do not deny or do not delete, that's removed from that resource if it fell out of scope of that blueprint. So then you can go back afterwards and delete that resource if that was something that you didn't want to have. However, blueprints, moving something out of the scope of the blueprint does not delete that resource. Okay, same concept is that if you remove the blueprint completely, all those resources that are part of that blueprint will still stay out there. So if you do a big, massive deployment as part of your blueprint where you're deploying, a bunch of databases and putting out a whole bunch of virtual machines, and there's this really nice application that you define and has all these resources as part of it, and you deploy it as part of a blueprint, and gave a nice, consistent deployment across all your subscriptions. It was really great, and it was really clean, and it was a great deployment. If it comes time for that application to finally be cycled out and you remove that blueprint, those resources aren't going to get removed. You're going to have to do a follow-on test to come back and remove those resources. Okay. Again, this is kind of a safety feature. They don't want somebody just to accidentally remove a blueprint and then all of a sudden you've lost your entire application. It's one of those just kind of a safety features. It does make the cleanup a little bit more difficult because now we have to go back and, okay, we've removed the blueprint, now we need to go remove things. But it's just that safety feature. So again, the big thing to keep about blueprints is that they have artifacts in them. Those artifacts are policies, role assignments, resource groups, and resources. You can then do blueprints. You can protect resources with either do not delete or cannot change read-only access. You also want to be aware of managing security for applications. When you're talking about managing those applications, Key Vault is a big key factor. If you're not familiar with Key Vault, you need to be familiar with Key Vault. That's where you store secrets, certificates, and keys. The idea behind a secret is that is a long string of some value. It can be a password, it can be a configuration string, it can be a URL pointing somewhere. The secrets themselves are just generic strings that you can put in any type of string data that you want. Certificates are object that is containing the key as well as the public certificate, so that you can store those for like TLS type of web pages. That's the type of thing you would use for certificate. Keys are then a method for storing keys that are used for encryption, especially around like disk encryption when you're, maybe having setting up the encryption disks for your virtual machines. Those get stored as keys in key vaults. And the idea behind a key vault is that you have the management plane, just like we would have for all the resources in there, but then there's also that data plane for key vault itself. That data plane is not managed by RBAC, and it's in preview right now, but as of this moment, that's not the released way to do it. The permissions for Key Vault are kept as a separate plane of access. You then have rights to doing key management, rights for doing secret management, and rights for doing certificate management. And this is also done at the Key Vault level. If you give somebody the ability to create and delete certificates, they can do that with all certificates in that entire Key Vault. If you need to separate out permissions for Key Vault or for certificates, you need to have multiple different Key Vaults. Ideally, you're also going to do least privilege management, so you don't give somebody the ability to delete a certificate if they're only going to be reading certificates. If you have an application out there that's storing your certificate, that application does not need to update that certificate. There are actually functions within Key Vault to allow you to automatically update certificates. And when you do that, the application just needs to be able to read that certificate. They don't actually need to be able to update it. You have the Key Vault service that is actually going to do the updates for that certificate, and then those applications can come and grab those updates as they happen. Because they're referencing this certificate object inside the Key Vault, they just go and read that, and when it gets updated, they get the update. You don't have to worry about them coming in here and doing some sort of automation and then pushing the certificate into it. The application can pull it out of there. Okay. Same type of thing with secrets is that the idea here is that whatever you're wanting to utilize that resource, whether it be a password for a third-party site, you can also put passwords in there for deployments. A common function is that for doing AD joins of virtual machines to a traditional Active Directory, you could put a the username passwords for the application accounts, or the user accounts that would be used by Active Directory to authenticate the machine to Active Directory. You can put those in Key Vault as 2 different secrets. You can then specify in the template, you can reference those secrets so that the deployments can pull those Key Vaults out. So in that case, what happens is that the user does not have to, the person doing the deployment does not have to have access to the Key Vault at all. They just have to know what that string value is to reference the string ID. They don't need to know the content of the secret. They just need to know the secret ID, which is going to be the Key Vault with the name of it, the name of the secret. Okay. You then, in the Key Vault permissions, you specify that they have the ability to deploy. So as an example of all these permissions that we're talking about with Key Vault, there's lots of different entries in there where we can specifying the permissions at the Key Vault where they have access to it. Those are the access policies of the Key Vault itself. Key vaults are also globally unique named, and they have a direct URL access. So for instance, this particular one, they're created for this month. This is the URL, and you'll see that their keys will be kept here, secrets are kept here, certificates are kept here. Your access policies, you can define, again, virtual machines for deployment. This is if you maybe kept secrets in there for a script to go off and execute against, you're registering against a third-party management tool, and you get the access in there. They also give the ability for the virtual machine deployment scripts to access the Key Vault. So again, the user doesn't have access to it. The virtual machine doesn't have to have permanent access to it, just access during deployment. Then the other options were Resource Manager for template deployment. This is where you can put in, like I talked about, the domain scripts as well, having access to domain joins. With that, then Azure Disk Encryption for volume encryption. These rights are special rights for services to have access in Azure explicitly without having to do managed identities or other types of access into this space. Those are special purpose ones. There is, like I said, the Azure role-based, but right now as they're recording, this is currently in preview. The Vault access is what the test will be accessing on it. The idea here between first thing of an access policy is that there are a few templates around management. You'll notice there's the key secret management, which gives you access to everything. There's also individual roles and individual management. There's also examples for SQL Server connectors, Azure backups. The idea here is that under key actions, you'll see that there are certain things that you're allowed to do. These are all the type of operations that are allowed, but these are the only ones that are assigned to this particular role. You can then customize beyond that and put those in there. At this point, all Key Vaults automatically have purge protection enabled. What purge protection means is that if you go in there and you delete a secret or delete a key, it is not permanently deleted yet. It is still sitting out there waiting to be removed from the environment. If you felt like you really didn't need to have that around anymore, you would purge it. Okay. And once it's been deleted, it'll eventually be purged automatically after 30 days. But if you need to get rid of it earlier, that would be deletion. So that is something that is now built into the default of all Key Vaults. It was an option before, it's now the default setting. You can also set firewall rules for Key Vaults, just like you do storage accounts, where only certain IP addresses have access at all to the Key Vault. You'll need to make sure if you do private connections that you allow Azure resources into it as well. If you're doing it for any of the Azure resources like deployment and whatnot. Again, granting access to the network does not mean that they immediately have access to the Key Vault. It just means that they're allowed to authenticate. If you deny them network access, then they won't even be able to attempt to authenticate. You can also put Key Vaults with private endpoints, Private endpoints, if you're not familiar with those are what the virtual networks can use to directly access resources over the private address space and not have to be netted out and go through public addressing. Okay. Again, there is management control through the access controls through RBAC standard setups, but for access policies is where you set up all those configuration pieces. When working with applications, a big key factor is managed identities. What managed identities are is they're an entry within Active Directory that they can utilize to authenticate. You can then assign rights to that managed identity just like you could any standard user to grant them specific role access to resources within Azure so that you can you don't have to worry about storing a username and password. There are two main types of of managed identities. There's system assigned managed identities and user assigned managed identities. The system managed identities are ones that are created by Azure for a particular application, is only used by that application and nothing else. When that application falls out or stops using managed identities, Azure deletes that managed identity. If you need to have more customized setup, you can do a user managed identity. In those particular instances, you create the identity yourself in the portal, and then that can be used by multiple different applications. However, for some reason it stops being used and you don't use it anymore, you're responsible for going out and removing that identity out there. Again, the idea here being is that this is initially a user and password that you have to keep out there and have to have stored in a key vault for them to go access. This is something that's a revolving authentication. Okay. You can then also register and manage applications in Azure AD. These are the applications that you can use to authenticate and connect with Azure Active Directory. You just need to be able to understand who can register. By default, you may change it to where nobody can register. You can set it to where all users can, or you can set where administrators can register, or an individual user can register. So be cognitive of those types of identities within Azure AD. These are some Skill Me Up labs that are available to get you more familiar with these ideas. Building a function will help you with how you can utilize key vaults and working with Azure functions out there, as well as logic apps. And also migrating on-premise applications to Azure will get you more familiar with integrating with those. The final section on the Azure 303 that you need to be aware of is the implement solutions for apps. Again, this is 10 to 15 smaller, but is definitely still important. You need to understand the application infrastructure as well as container-based applications. When we're talking about application structures, we're talking about configuring Azure App Service, as well as considering Azure Web App Service for containers and configuring app service plans, and then also configuring an app service. In addition, there's configuring networking for an app service, as well as deployment slots of an app service, and then finally logic apps and functions. We're looking at creating configuring app service. The idea of an app service is that it's a web-based service, and it can be either a Windows or Linux-based core, and then you have a programming language that's on top of that, whether it be .NET, Python, JavaScript, Node.js, or whatever other language that is supported that you're looking for. That's the main scope of the app service. And the app service is usually going to define what type of processing power is going to be behind it as well. And these are actually going to be applications defined within a web service. If you're familiar with the Windows management, it's similar to doing IIS and IIS sites. The app service is going to have its own configuration settings as well, where you can put in things like general connection strings. You would want to reference out what the key vault secrets are, but you wouldn't want to store the actual logins in the configuration. But you can put in maybe like database server name or an external app service, or whatever type of configuration settings you need for your application that may have been kept in like a web.config and IIS, you would put that same type of details in the configuration of the app service. Now the app service is going to be running interpretive code in your space. You're going to have that .NET app out there. You're going to have your Node.js, that type of things running as just a web app. There's also the idea of maybe wanting to run a container, and for container, you're running a Docker container, and this can be something that is within the Azure container library, or it could be something just running the web space. So this basically is just the ability to run a container. It does not give you any real orchestration as far as like spinning up and spinning down, just it gives you the ability to run the container in the Azure web space. You then have the ability to put multiple different app services together in an app service plan. Much the same idea of a dedicated host or in dedicated space. The app service plan lets you be able to run multiple different services in, sorry, that's app service environment. I don't know why it's an app service plan. App service environment is where you can run multiple app services together. Anyway, and then also there's the configuring the networking for the app service environment. If you do an isolated app service and you're putting in the isolated app service environment, that can be in your own private networking space. And so that can allow you to have networking that way. You can also configure your app service to have a limited networking interface so that it can only access from particular IP addresses like you would for similar to what you would do for a firewall for a storage account. You can then configure the app service to where it's only routed through like a application firewall, or excuse me, application gateway with a web application firewall. This way you can ensure that while the app service itself is in a public facing structure, it is only limited to access by your application gateway. So you're sure that anybody that's accessing it is only going through your application gateway. Another big option with the app services is the management slots. Depending on the size of your management, size of your app service, you can have multiple different management slots, management deployment slots. The idea behind a management deployment slot is you get multiple different versions of your application defined in the configuration of your app service. So you put in that app service and you have a running primary application copy. You can then put up a new deployment slot where you can deploy in your code into another deployment slot. You can then reference that deployment slot through via a unique URL so that you can see it running directly in Azure if you know the exact URL to get to it. You then have the option with a deployment slot where you can slowly move it in to your space, where you can maybe have 90% of your clients hitting your primary site, and then maybe having 10% hitting your first deployment slot. So you can slowly see how people are using the app, make sure that it's working within a load, and you can slowly increase that percentage. You can also do a swap of the deployment slots, so that you can have your primary one, and then you have your second deployment slot. You can then swap those so that what was your primary slot now becomes your secondary, but what is your secondary now becomes your primary slot. And so whenever somebody references the main URL, they're always going to hit that secondary slot. One thing you want to be careful of if you're going to do swapping of your management deployment slots is these are multiple different instances, and sometimes you'll want to warm them up before people actually connect to them. If you have a management slot and you deploy something out to it and you tested it 3 days ago, a lot of the stuff that was in memory for that application are going to be paged out. It may not be immediately available on the app services, and maybe not as quickly available and put into memory cache for those app services. And so it was sitting there cold for a couple of days. You swap it out, you're now going to have to wait for that app service to go out and grab that stuff and pull your code back into memory. So it's really important that before you do a swap, you want to access the direct URL for that application, for that management slot that you're about to swap to. using its direct URL and just preload some of that data probably. Then once you swap it over, it's in memory, it's immediately available. So one thing to keep in mind when you're doing those deployments. Then we have your logic apps. A logic app is a workflow process. It's actually defined again by JSON in the backend. We use JSON a lot in Azure. But it gives you a nice GUI interface in the portal where you can actually select off multiple different places. These can be triggered from lots of different options. You can trigger them from a file being placed on Azure Files to a Twitter lead going up. You can then feed off those results from the different objects into other resources. So if you wanted to, common one they give is you have a tweet coming in over Twitter, you can then feed it over to your cognitive services and have the cognitive services determine whether or not the text of it is, something that's happy or something that's mad. And then the cognitive services can return back to the logic app saying, this was the point score, so then you can say if there's anything below 0.7 in your cognitive solution, meaning that wasn't, somebody wasn't really happy about it, you can feed that over to a customer service group to have them review it and figure out what needs to be done. Or, if it's something that looks really good, you can maybe put it over into a thread of saying, thanks for thinking about it. I think you could actually do a tweet, or you can send off to your management or marketing team to look at them to put it into marketing tools. And so those are the types of things you can have it do all within a logic app. Again, you have it say, hey, when a tweet's put out on this account, you connect it up to your Twitter account. And feed over to this cognitive services, you connect up to the cognitive services. The cognitive services process it and send it back saying, hey, give a score of 0.7. You can then put an if then says, hey, if it's this one, send it over here. If it's this way, send it over there. Logic apps are a really great way for somebody who's not really familiar with programming to do just a basic flow through the GUI and be able to reference out values as they come through. You need to understand how those implement and maybe what they can connect off to, what the triggers are. You can do time triggers, you can do trigger off of events, you can trigger from a webhook. There's lots of different trigger options. And then you can also integrate them with multiple different connectors. The connectors are what, basically are configured as authentications off to the external resources and services. Logic apps are also charged by each step within the logic app, so they scale very quickly because as many times as you want to run them, they'll let you run them as much as you want. You may be charged a lot for it, but they scale very quickly. If you want something with a little bit more feature set and a little bit more robustness, you can do the the Azure functions. Azure functions are basically small sets of code that can be triggered, again, through webhook, by REST API, by multiple different entry points, and they just run through a process. And they're completely serverless structure. They allow you to go off and just run a function as many times as needed. It's an easy way to have a very highly scaling solution without having to have any infrastructure in place. You basically just have a set of code that's accepting some parameters and spitting out a result. It's a very quick, easy process to have a scale of a serverless structure. You also need to be aware of implementing container-based solutions. In these cases, you're going to have container images. If you're not familiar with Kubernetes, we have a lab that you can do to go through it. You can have either the Azure Container Instances or Azure Kubernetes Service. Azure Kubernetes Service is a full orchestration where they basically, you have a deployment, it has a container, it has a pod, it's keeping track of those pods, it's keeping track of what the load is on those and scaling those up and down. That's what the orchestration is. You can then have the containers deployed through the Azure Container Registry. And a container, again, is just a definition of an application. Again, multiple containers together as a part of your deployment. The containers can be either pulled from the Azure Container Registry or from external third-party containers that you define. So you can have it pull from a public container source somewhere that you have another container. It can be, a provider that has an application that has a container already defined, Docker container, and you can pull that directly into your Kubernetes deployment. The Azure Container Registry also can be available externally. So if you have a container that you've defined in Azure Container Registry, it can be pulled from your on-premise container structure or another cloud provider if you wanted them to be able to pull from your Azure Container Registry. It doesn't just have to be used in Azure. And then finally, you have your Azure Container instances. Azure Container instances are not a full orchestration. They're basically the ability to run a container in Azure. This is something that you would usually use with your own orchestration service. So if you had Kubernetes on premise and you wanted to be able to scale not only to your local systems, but also be able to scale to Azure for additional load, you could use your on-premise Kubernetes and then use your Azure Container Instance to deploy containers up into Azure. This is not going to be doing the full orchestration with the Azure Container Instance. It just gives you the ability to have another container platform to run your containers on top of. If you want to mainly go out there, you can create a container and then you can spin them down. But usually the idea behind most containers is that we want a very dynamic environment that's scaling up and scaling down based on your load. It's usually a pretty automated process. You go off and just do a deployment of a container. If you have a long-running website that's going to be just happens to be deployed in a container, you don't want to do a full web app when you definitely don't want to pay for a full VM, but it's just something that's already been prepackaged as a container. You could go off and deploy that container and just leave it running if you wanted to. But usually the big thing with containers is that we're wanting them to spin up and down and scale out and scale up. And so for that, we're going to need an orchestration. AKS is Azure's solution, Azure Kubernetes service, but you can use third-party services or third-party orchestrations if you wanted to. If you want to learn more about those, you can look at the Getting Started with Azure WebOps class, as well as the deploying Azure Kubernetes clusters for Linux and the Azure CLIs as an example. And the final section is the implementing and managing data platforms in Azure. Again, this is another small one, but the idea here is that we have your NoSQL databases and your Azure SQL databases. The main idea behind NoSQL databases is that we have a database structure that is not initially as tightly bound as your SQL structure. So it gives a little bit more flexibility and gives you a lot more ability to do dynamic pieces. So you don't necessarily have the overhead that you would have in a SQL environment. And you have potential dynamic load growth. There are two main types of NoSQL that you're going to be working with in Azure. The main one being storage account tables. The tables that actually contained within storage account are a NoSQL table. Frequently, you bring the table in and out as just JSON elements. That's frequently how you reference it. You can have up to 250 columns. Every row object in the NoSQL system does not have to have every property or every column defined. It makes it very easy to just start dropping data into the table and still have it somewhat structured. It's not necessarily rigid as a SQL, but you can just say, hey, just add this element to this table, add this element to this table, add this element to this table, and then, hey, give me everything in this table that has this property value. And you can store all that in just a storage account table by just creating the storage account and granting access like you would for accessing the blobs. It's a very quick way to keep track of those elements. However, they are limited in the scope of it is contained within just that table within that storage account. There isn't really interacting joins. There's no real replication between sites. It's just really that table. It's a very basic structure, but it's a quick way to get NoSQL. When you look for more of an enterprise type of solution, where you're looking for something that's more globally available, that's where you're looking at Cosmos DB. And Cosmos DB is a very large potential solution. It is globally scaled, and there's multiple different ways to manage it through different APIs. Sorry about that. Anyways, Cosmos APIs. There's the Cassandra API, Gremlin API, MongoDB, Table API, and SQL API. The whole idea behind these APIs is that they give you different ways to access the data that's in Cosmos and whatever is appropriate for your application and your solution. MongoDB is a common NoSQL structure and interface that is common, especially in research environments and some educational type of environments. It's a very common platform out there for NoSQL. MongoDB API for Cosmos DB allows you to use Azure's Cosmos DB, but still use the interfaces that are common for your MongoDB deployments. So if you have a solution based around MongoDB, you can utilize that API to access the Cosmos DB that's in Azure. Also, there's the Cassandra API that is used by enterprise environments, as well as the Gremlin API. And then the SQL API lets you utilize a lot of T-SQL type of commands and SQL interfaces to be able to use the Cosmos DB platform with more of a SQL interface. So if you have an application that was SQL based, you may actually find you can move the code relatively easily over to Cosmos DB by utilizing the SQL API. And then finally, if you had an application where you had built it around SQL tables, and then you realized, or not SQL tables, you had it built around storage account tables, and then you found that those just were not doing everything that you need to, it grew up and it was just extending beyond the performance limitations, or the you need to have something a little bit more enterprise ready, scaled a little bit more than the storage account. You can actually use a table API to where the same commands you used for the storage account tables, you can then use for Cosmos DB. So you can almost reuse the exact same code, you just change what the interface is. You can then define what the replicas are in Cosmos by saying you want to replicate it between what regions, what type of replication you want it to be. That can be configured by the Cosmos DB. So it doesn't matter what API you're using to access the data, the replica management that you defined underneath it was managed through those. In addition to NoSQL databases, obviously we also have Azure SQL. Azure SQL is the PaaS offering that Azure provides for SQL environments. The big thing you need to know about here is the SQL databases. You specify the size by the SQL databases themselves, as far as like performance, the size of the database, all those configured at the database level. The database then sits on top of a SQL Server resource. However, the SQL Server resource is more defining around a grouping of databases as well as management interface. But that does not, the SQL Server does not define the performance. The performance is defined at the database itself. In addition to having SQL PaaS interfaces, you also have the ability to do SQL database managed instances. But SQL database managed instance is that it is a environment where you're running SQL in a managed VM space where Azure is responsible for the virtual machines themselves. They reside in your virtual network space as if they were just another VM. However, you don't have direct access to the virtual machine itself. They manage all the scaling, they manage all the growth, but it's a dedicated virtual machine space for your SQL databases. These do take a long time to deploy, hours usually to deploy those SQL managed instances. However, once they're deployed, you can scale them up and they will scale them automatically, and then you can scale them back down and they will scale them down some. But you need to make sure that that's, that you're planning on that. That takes a little while for the initial deployment. Again, they exist within your virtual network space. Okay. They also configure the high availability of those virtual machines, so you don't have to worry about setting up load balancers. You don't have to set up the cluster replication. They manage all that high availability in SQL managed instance. If you need to do disaster recovery for the Azure SQL databases, you need to be aware of what those or replication options are for the SQL databases. You also need to be aware of the SQL backup options, or SQL backup can be is done automatically for SQL databases and PaaS. You also have the option of backing up and managing SQL directly running on even your own VMs. If you run your VMs, if you deploy the image for SQL from the marketplace, it'll automatically install the agents for managing that SQL directly in the environment, so you can see the health of the databases and manage those databases directly in Azure portal. You can also add on the extension to an existing VM that you already have that's running the SQL that you've deployed on there. You can also add on the agents for doing those management pieces. Okay. However, if you deploy SQL to your own VM, you're responsible for the high availability, the replication. You can utilize Azure for doing the backups, but you still have to configure and manage all the virtual machine itself. So when thinking about the management aspects, the SQL on Azure VM is the most management, but also the most versatile setup for you. The SQL managed instance has it to where they've taken over the application needs for you and the scaling aspects of it, but still is a private dedicated space. The Azure PaaS gives you probably the most flexibility for growth and dynamic structure, but that also gives you the least amount of configuration as far as what you could run in those particular environments. And then finally, publishing the Azure SQL database as far as importing and adding in data into it. You need to be aware of how you can pull that data in and then make that available in the environment. You also need to be aware of the firewalls and options around that. There are some labs around the environments as well. The Storage Explorer is useful for browsing through the NoSQL setup for the tables, also doing some of the blob SQLs, but also the managing documents. And Azure Cosmos DB is really good for understanding how Cosmos works. And then creating and migrating a SQL Server database is really good for understanding how SQL works. Another big thing is the exam questions are typically action-based. You need to make sure you're understanding the technologies, whether it be the portal, the PowerShell modules, and the CLI, and also be able to perform the work. The AZ303 is not intended for somebody who's never touched Azure before and just seen it in books. You need to get some hands-on it. If it's something that where you're willing to learn and get into the environment, that's fine, but you need to at least have a lab environment, and you need to have some real understanding of working with it. Hopefully you really should have 6 months experience at least in Azure in some way, even if it's just somebody who's looked at managing Azure. But the idea behind this is it's going to be an architect, somebody who's designing things. So you really need to have good understanding and working knowledge of Azure. You need to have had some time to be able to perform the work and be able to do it. The architect isn't just somebody who's theorizing it, somebody who really understands how things are going to interact. So part of this exam is expecting you to go in and actually make changes in the Azure environment. The Skill Me Up Labs will give you a full-fledged Azure environment. You have the exact interface of Azure to go in and use those resources. So it gives you a nice live environment to walk you through and exactly see how you would do the specific tasks in Azure. Usually guard away. If you're not going to use that, there are free trial options for Azure where you can set up Azure for a month for free, and they give you credit to run whatever you want on that Azure space for a while. But those are obviously limited in time and budget. You can also pay for your own space, but Azure can get pricey, so be aware of what it is. Try and use that Azure space if you can. Also, if you have MSDN subscriptions, if your company has a lab environment that will let you use that. There are a lot of resources that are basically free in Azure. Most things are pay as you go. So if you just want to go through and create one and set one up and destroy it, the cost even then is usually relatively cheap. Just don't leave it running out there for days and days, because that can cost your company a lot of money. So. We talked about the drill exam. We talked about implementing the Azure infrastructure, as well as security solutions, and then followed on with apps and containers, and finally the data platforms. These are the main topics covered in the AZ303. We appreciate you coming in and taking the time. We can't stress how excited enough we are to have you working with us. We hope this provided you enough background to understand the environments and how to pass the AZ303, what's covered in it. If you have any questions about something that isn't here, please feel free to reach out to me if you'd like. We're always looking to improve, and if you don't let us know, then it's kind of hard to improve that, but I'd love to hear if you have any other questions or would like any improvement. If you're looking at doing the exam, feel free to reach out to me on LinkedIn and let me know, and let me know how it goes. If you want any help, and love to hear how things are going for you. And thank you again for working with Scale Me Up. My name is Kit Skinner, and this course was developed as part of Ops Agility. Scale Me Up.